Django, I hope we can wait for another 2 or 3 more minutes so that
yes, of course.
Participants are joining slowly. Yeah. Are we good to start? Yeah, Django, can you hear me?
Yes.
Yeah.
Yes, I can hear you.
Yeah. So good morning to day 3 of Open Source Summit India 2021. Today we have the IoT and security track. So the first session will be by Django Isidorovic. He's founder at Nova Vector from July 2019, and he's also the co-founder of Mainflux, which is an open source IoT platform. He's based in Serbia, and he's also been an ICT innovation manager for Nelt Grupa. He's got immense experience in IoT, and he did his telecommunications engineering from the University of Belgrade. And we're extremely happy to welcome you, Django, to Open Source Summit India, and I hope it will be a beneficial session for all the participants. So over to you, Django. The stage is all yours, and you're all yours.
Hi, everyone. Thanks for the introduction. So we can skip this slide. Thank you for having me in the Open Source Summit India 2021. And today we'll talk about the Internet of Things, and I'll try to share my view on the technologies involved from getting the data from the ground and pushing the data to the cloud, and then getting back the automation from the cloud back to your edge devices, etc. So one of the questions that I still get quite often is, why are we talking about Internet of Things only now? We are like 50 years or more into industrial automation, and machines have been talking to machines for quite a long time now. So the question is, why are we talking about Internet of Things only now? Well, the most important difference between now and 50 years ago is that the cost of embedding technology into the devices and objects.
Janko, I'm sorry to interrupt you. I think your video is off.
So can you hear me?
I think your video is off. Your video.
I can see my screen. I'm connected to YouTube channel, and I can see my video on the YouTube.
Okay, I think it's not. We can see only your display, your headshot and the Zoom. It's okay, never mind. Yeah.
I'm not sharing the camera. I'm sharing the screen.
Yeah, your camera is off.
So on the YouTube, it says Internet of Things, so I think that the streaming is working. Should I continue?
Yeah, sure. Sure, Django, please go ahead.
Okay, thank you. So, as I said, only recently the technology and the cost of embedding the technology into objects has reduced so much that you can actually create a connected object without increasing the price of the object significantly. And the other thing that is also very important is that only in the recent 10 years or so, the connectivity providers and telcos have improved their networks to the level where they can connect billions of devices to the network without disrupting the connectivity. So those are the two basic building blocks of creating an Internet of Things ecosystem. And as a definition, this is one of the definitions that I like and use, is that the Internet of Things is the network of dedicated physical objects that contain embedded technology and are able to sense or interact with their internal state or external environment. And the Internet of Things ecosystem includes things, communications, applications, and data analytics. So it's not just your smart device that's connected, but it also includes the whole applications behind the curtains that actually do something with the data that you gather from your device. And when we talk about the IoT in the enterprise, the manufacturing and creating new products has changed significantly over the last 10 years, or even less, even the last 5 years. Now your car needs to be able to push the telemetry data to the manufacturer's cloud, and you expect your manufacturer to send you the information when do you need to go to a service and to which service shop you should go to preventively repair your car. And this brings a lot of strain to the small companies because they don't have the infrastructure to do such things, and the market is basically expecting every company to produce a smart device nowadays. If you're pushing a new product to the market, you have to be able to smartify it in some way. And there is still a cost to that, not just to create the device itself, the product, but also to do the integration within the systems within the enterprise. And you need a lot of people to manage the backend servers that your new products are connected to. And it's really hard for the small companies to compete with the big companies in the market. And this is why the open source initiatives are so important, because it actually tries to level the field and provide the small companies and the small teams ability to really create a innovative product and push them to the market in a reasonable amount of time. One of the other important things in the IoT is the fragmentation of the IoT, because as I said previously, you have maybe 50 years or so of machines that are able to communicate to each other, especially in the industry mostly. Even you will probably not encounter such an old machines. You will have chance to work with machines that are in production for 10 years or so, that are perfectly fine, and they are able to produce the products that are required. And they have old communication protocols, are not up to date to new standards, but you have to be able to work with them also. And even the new machines, they have different protocols, or even if they use the same protocol, it's a different implementation, etc. Then you have different kinds of networking, and I'll get into that later. And then you have to worry about the scaling, and then integration with the enterprise softwares, and then there's issues with security, and all those issues can be solved in a different ways. So there is a lot of fragmentation in the IoT landscape. And at the end, you have public and private clouds, where you want to push your data, be able to process it. And then you have Internet of Things edge solutions for the cases where the latency to the cloud is not acceptable. So you need to do processing near to the data source. And then you have to be able to visualize the data and get the insights and information from the data to the people that need to make decisions. This is just one example of fragmentation in the IoT. This is the landscape of the IoT startups, and IoT analytics research team has been able to find 1,200 plus IoT startups, and I personally know at least 4 or 5 of the startups whose logo I did not find on this slide. So it's probably double the number of the startups that you have, and all these things lead to the fragmentation, because there is so many standards, and each of the startups is bringing something new to the IoT world. So how does this look in real life, in practice? We start from the ground, and we try to get the data. And your IoT project can be in smart agriculture, smart industry. You may be working on a smart city solution or smart energy. And from the start, you have diversity. And the requirements for the smart agriculture are very different from the smart energy. So it's really, when you create an Internet of Things platform, you really have to make it modular and scalable, and try to make it as universal as possible. This is one example of the implementing open source solution in the smart agriculture. And first thing is you try to find on-off-the-shelf sensors, so you don't have to build your hardware, and you try to integrate your the off-the-shelf hardware into your solution. And the first thing is your sensors have to be IP67 sealed. Water and dust don't do damage to electronics inside. And then you have to be able to operate in an outdoor environment, so temperatures go from -30 centigrade to +50 degrees centigrade. And then you have connectivity issues because in the rural area, your connectivity might have problems, might not be so stable. The sensors have to be battery powered, and those batteries have to last for a couple of years because you don't want to go into field and change the battery every month or so. And then the data that you're gathering from the soil itself, it's a low frequency data, so there is not much data there. And when you take all those things into account, you are able to create, you have to create a solution that works. And the most important thing is that you have to provide networking that will work on the field and that will work with the low power, battery powered devices. So when you look at the networking options that are out there, there's quite a few of them. I just took a couple as an example. You have sub-gigahertz solutions like LoRaWAN and Sigfox, and then you have 1.4 gigahertz solutions, which is standard mobile telephony frequency. And there you have a narrowband IoT or LTM. And then where available, you can have 5G, but mostly in rural areas, there's no 5G still. And you have to take a look at your range that you need for your project. So you have long range networks, short range networks, and then you have long range networks with low power. So when you're designing the solution, you have to start with networking and the power requirements. So your devices need to be battery powered, and then if your key factor for the IoT solution is network range, then you probably have to go with the sub-gigahertz solutions like LoRa. Also, if the power consumption is your key factor, then the most strength you can find in sub-gigahertz solutions like LoRa and Sigfox. But those solutions have a bigger antenna size. So if your limiting factor is antenna size, then you would probably go with mobile networks and mobile solutions like narrowband IoT or LTE-M. And also the sub-gigahertz solutions provide much lower data rates than the 2.4 gigahertz solutions. So if you need high data throughput, then sub-gigahertz solutions like LoRa are out of the questions. So for the smart agriculture, you would probably go with LoRaWAN, and you would probably push the data directly from the sensor to the cloud using the LoRa network. But when you get the data, when you go and implement your IT solution in the industry, you have a different requirements. So your sensors now are most likely indoor, and you have different kind of connectivity issues because you might find yourself in a high radio frequency noise environment where your networking might be you might have issues with the radio noise, and then you have different kinds of sensors. So you might have a mixture of battery powered sensors or powered sensors, and you also might have to connect to the PLCs that already exist in the production line. And the data frequency in the industry is much higher than the data frequency in the agriculture, because those machines are producing maybe, I don't know, 10 or 100 or 1,000 products per minute. So if you have multiple production lines, then your data is really going to ramp up quickly. And you'll have probably a few dozen millions or even 100 millions of messages per month. In the industry, you also find an additional problem because most of the machines in industry are already smart, and they have some PLCs and ability to send the data. But the different manufacturers and different vendors have their own standards, and you find yourself in a situation where you have the data, but it's in the islands, and you might not even have to connect to machine itself. You might be just able to extract the data from the solutions that each of the manufacturers provide. So your Internet of Things platform might be also a system of systems or something like that. And then you would actually just add additional sensors for the stuff that you cannot get from the PLCs. This is most likely scenario that you will encounter in real life when you're deploying your IoT solutions. You'll have to have a mixture of pulling the data from the software that's provided by the vendors of the manufacturers of the production lines, and then you will have to add additional sensors to get additional data that's not recorded by the manufacturers, or just add the human interaction. And then you have two ways of pushing the data to the cloud. You can push the data to the cloud directly, and it has its advantages because it's simpler. Cloud usually has infinite resources, so it's really scalable, and it's usually easier to manage because clouds have built-in management tools. But sometimes the devices generate large amount of data, and then it can be costly to push all the data to the cloud. Also, it requires a high bandwidth. So this also might be an issue. And then what happens if the connectivity is lost? The devices are not often smart enough to be able to store data locally and then send when reconnected. Also, there is an issue with latency. Sometimes you are not able to work with latencies that are 200 milliseconds or larger, because usually it takes between 50 and 100 milliseconds to push the data to the cloud. Then you have to spend some time processing it, and then if you need to push data back from the cloud to your devices, it's another 100 milliseconds, 52 to 100 milliseconds. So you have to think about the latency. And then there's privacy issues. If you're pushing all the data that your devices are gathering from to the cloud, you might encounter regulatory and privacy issues. So one of the solutions to the issues that you have when you're pushing data directly to the cloud is to add an edge devices and do some processing locally close to the devices, and then push just parts of the data to the cloud. This solution allows for lower latency. If you're able to locally process the data signal, then your actuation loop is sub-millisecond or like 1 millisecond or something like that. And you can do data filtering on the edge and push only part of the data to the cloud, meaning that if your thermometer is reading the temperature and temperature is not changing, there's no need to push the data every minute to the cloud. Maybe you can just push those temperatures that are changed. So when you record the change in the temperature, then push this data point to the cloud. And it also reduces the privacy issues because you can filter out the data and do some processing of the data locally, and then push just processed data to the cloud. However, the downside of introducing edge is that your system becomes more complex, and you have to be able to manage your edge devices also, not just your cloud. And on the edge, you have limited processing power, so you cannot train your machine learning and artificial intelligence models on the edge. You have to train them in the cloud and then push the models to the edge and do data processing on the edge. And it means that you have to have multiple admin privileges and basically multi-tenants on the edge, because your AI team should not have the rights that your networking management team or device management team has on the edge. So when you get your data to the cloud, that's the easy part. That's something that we all are accustomed to now, and we all develop applications for the cloud. So we are able to do processing on the cloud. We can create models, machine learning models on the cloud, and extract actionable knowledge and information from the data we get. But IoT is not magic, and it will not resolve the problems by itself. You have to integrate the IoT solution to the enterprise, and you have to provide the people with the near real-time decision-making information, so that people can act on the data you get from your IoT solution. So cloud, of course, solves the scalability issue. As I said, it usually supports large number of devices. You will have fault tolerance built in. And if you use concurrent programming languages like Go or Erlang for developing your applications, then your scalability is really limitless, practically. You would have to work with the microservices, of course, be able to put them in containers and deploy containers. And your IoT solution should have to be modular because in the different environments, you would need to be able to scale different parts of your application. Meaning that if you have just a few sensors and a few thousand of users, then your device side of IoT solution would not have to scale as much as your user side of your IoT solutions. And then in some cases, in some other cases, you would need to connect thousands of devices and have just a few admins in the system. So your device services would have to scale and your user services would not have to scale. Of course, you would need to get some data visualization from the cloud, and cloud is really good for this because it allows you to access the data from anywhere. Usually it has multi-tenancy built in and you have fine-grained access rights. So the cloud provides really good stuff for the IoT. But then you have to push the data back and your machine learning models back to the edge. And this is where the IoT continuum starts to be complex. In cases when your cloud latency is too high and you cannot work with a few hundred milliseconds of latency, you have to introduce edge computing. And then if your data rates are too high, you have to do data filtering on the edge. Also, connectivity might be the issues. In some cases, when you have actuation, you cannot allow for the connectivity issue to occur and disrupt the automation. So you need edge computing and edge automation there. And you have to be able to push the commands from the cloud to the edge, and then from the edge to the smart devices. And as we said in the introduction, I was involved with the edge computing project of the Linux Foundation called the EdgeX Foundry. I was member of the technical steering committee from the project start until we released the version 1.0. That was for a couple of years until 2019, I believe. And when we talk about the edge computing, EdgeX is really a good example of how you can create an edge computing solution. And this is basically a set of loosely coupled microservices. You have device services on the south, and then you have application services on the north, and you have core services and the supporting services in the middle. So it's like a double transformation engine, basically, where you get your data, you transform it to internal data structures, and then using application services and protocol of your choice, you can transform it again and push it to your cloud infrastructure, to the cloud infrastructure of your preferences. So how does it work? Basically, you have device services that support different protocols, and then let's say you have your Modbus device, you can push the data from Modbus device to the Modbus device service. Then the data would go to the core data service, and then application service would get the data and push it out to the cloud. And if you need to do some local processing, you can use a rules engine to process the data and maybe push commands back to the Modbus and back to your Modbus device. This architecture, as I said, is based on a microservices framework, and you can deploy it as a set of Docker containers. And this allows for different topologies of your edge computing solutions. So you can have edge gateways where you have only core services and maybe a few device services, or a single device service. And this might be your low computing power edge gateway. And then you can have more computing power on intelligent edge gateways and have a tiered deployment where you push the data to one edge, then you push the data to edge device which has more power and maybe more processing and can actually do something with the data, maybe some analytics there, and then push the data back to your devices, or you can export it there to folk servers and then push it all the way to the cloud. Depending on the industry, you can have different topologies, basically. If you're working with the energy plants, like wind or solar power plants, you usually have enough processing power on the devices themselves there, and you can maybe just link them and push them straight to the cloud. And then if you are in the smart building environment, you might need to have a set of edge gateways on one floor or in the building then as a next tier, and then maybe in a city for all the buildings that you manage within the city, and then push on the later to the cloud. And then if you are in the logistics and you have mobile fleet of trucks or vehicles, you usually push the data directly to the cloud without any edge computing in between. And this is one tiered edge deployment example where you have your smart building solution maybe, and you have edge gateways on the room level that are processing getting the data from your backnet or devices, and then you have more intelligent gateway with more processing power, and then on the building level maybe you have an edge server in your data center, and you're able to aggregate the data for analytics and check the overall building performance straight there on the edge. And then only then you can push it to the cloud so that the managers can access the data from anywhere. And when we talk about processing on the edge, we have to keep in mind that the data visualization on the edge is extremely important. And from my experience, the biggest improvements in the deploying IoT is actually providing the data to the people that are working on the production lines. And this gamification of manufacturing actually brings the most improvements. So it's really funny to think about it, that you have to implement really enormous amount of technology and connectivity and processing just to provide 3 stack graphs to the people that are working on the production line. And this was actually the biggest improvement that we had. Of course, when we talk about the Internet of Things, we have to talk about security. And IoT security is actually the next level, the next layer of security and that you add to your cloud services. Because when you think about the IT in general, especially in enterprise, your servers are in the data center or in the server room, they're physically secured. But in the IoT, your devices are out there in the field and they're physically accessible to the people who might not have to be uh, of goodwill, and you have to think about the security on the device itself. And then if the device is secured, you have to think about security of the gateway, which is also probably outside of your data center. And then when you secure your device and your gateway, and the data is getting to the cloud, then you have your standard securities for the cloud gateways, front end, back end services, etc., etc. But with the IoT, you have to secure the device itself and the gateway in the field, which are physically available to the malicious people. And you have to be able to have a secure, trusted environment, secure, trusted execution environment, and you have to be able to store the keys and the passwords in some kind of vault, and this vault has to be secured by hardware, and you have to have hardware root of trust, but you have to be able to provide those keys and those passwords to services that need it, and not to the malicious services. And there's also an issue with the random number generators on the low power devices. So you do have to have some kind of secure boot built into hardware, but you also have to be able to provide some access management to your edge devices, especially when you have machine learning on the edge. So you have to have some kind of authorization roles and resource owners and clients, etc., etc. And that would conclude the presentation for today. Thank you very much. And if you have questions, please let me know.
Yeah, thank you, Django. So participants, you can unmute yourself, or you can put the questions in the chat window.
Let me open up chat window.
Django, we've got one question in the personal chat. Yeah. So what is the future of open source in IoT? So how is the industry going, integrating open source and IoT?
I had multiple voices coming through, so I wasn't able to hear the question.
Yeah, the question was, what is the future of open source in IoT? How is it being integrated in the IoT, open source in IoT standards?
I think that, yeah, I have seen that. I have seen and witnessed. Oh, someone has YouTube.
Django, we can't hear you. I think your voice is breaking.
Someone has YouTube on the. So, if everyone can mute themselves, that would be helpful. So I think that IoT and open source will. I think that open source is basically a building block for IoT at the moment, and it really helps create Internet of Things solutions because it provides a building blocks, and it helps standardize.
Django, can you hear me? I think you're all.
And it helps standardize both the connectivity and the networking and the security. Yes, I can hear you, but there's a feedback. Looks like there's someone on the YouTube loop, and there's a like 10 or 15 seconds feedback.
Yeah, that's actually for the participants. Yeah. Django, I think we don't have any more questions from the audience. So thank you so much for being part of the Open Source Summit India 2021. And we hope to get in touch with you for future events also. Thank you so much for joining in from Serbia. Thank you, Django. Django, can you hear me? Yes, so thank you, Django. So next we have the session from Sayan Chowdhury. Sayan, can you hear me?
Yes, can you hear me?
Yeah, I can hear you.
Cool.
Yeah, so yeah, I'll quickly introduce you. Sayan, can you switch on your camera?
It's switched on.
Yeah. So for the next session, we have Sayan Chowdhury. Sayan is a software engineer at Microsoft, and previously he was working for Kinvolk. So he's a passionate Python developer. He's a tech talker. So he's currently working with Microsoft, and previously, as I've already told you, was working with Kinvolk as a Linux software engineer. He's also associated with Red Hat as a senior software engineer. And it is our pleasure to welcome you, Sayan, once again to Open Source India 2021. And over to you to begin the session. Thank you.
Thank you, Jacob. Thank you for the warm introduction. So yeah, I'll just set up my screen. I'll share my screen here. Oh, wait a minute. Is my screen visible?
Yes, it is visible.
Great. So good morning, everyone. I am Sayan. So today I'll be taking off Flatcar Container Linux workshop, and thanks to the organizer for giving me this opportunity to present this project, which I've been working on for the past 1 year now. Before diving more into the workshop, let me tell you about myself. So I'm Sayan. I work for Microsoft. I previously worked at Kinfolk and was working on. I joined Kinfolk in 2020 and was working primarily with the Flatcar team. And Kinfolk was recently acquired by Microsoft. So uh, even though I am working with Microsoft, my work remains the same, and I continue to work with the Flatcar projects, and I and working on to grow the community more and get more contributors into the project. So we have a lot of opportunities in this project, so that this whole workshops totally falls into the line where if you're interested in doing your first open source contribution, uh, do feel free to reach me out. I have my Twitter handle and email on the screen. So if you have any questions, do feel free to reach me out. Now, moving ahead, so I'll give a small idea on how I want to proceed with the workshop. So I plan to have it as a hands-on workshop rather than just a talk. So the idea would be to spend a couple of minutes first introducing what is actually Flatcar, and then diving into the doing the hands-on workshop. Now the thing is, I know like the time might not be a lot, like it's only 1 hour, 1 hour, a bit more than 1 hour, but
Yeah, we have 1 hour 15 minutes time. The next
right,
session is
yeah,
only at 11:30. Yeah.
right. So then also like I would like to prefer uh, quality over quantity. So we will go through it slowly, take it slowly, try to understand whatever we are seeing, and not hurry through the slides and through the demos. So I would request you to all to ask me any question. Feel free to stop me. Let's do it in the interactive manner. And I know like a lot of folks might have questions, or even if you're afraid to ask, just feel free to type those questions in the chat, and I'll be looking into it and try to answer it. And also like feel free to stop me whenever you have any issues and any problems following the whole workshop. So yeah. So before diving into the workshop, let me tell about what is the project about. So it's a Linux distribution, and it's primarily focused for containers. It's a very minimalistic distribution for containers. So containers has spawned up in the recent times with the advancement of the technologies like microservices. You have Kubernetes and stuff. So a lot of companies are actually going for the container based deployments. So that's where the necessity of a container focused container focused Linux OS came into place, because we have a traditional OS which people use for desktop. The same, there might be a couple of spins around, like, but traditionally the software relies on the same principles and is released for the servers and stuff. But then around 2015 2016, there's this new OS that came into picture, which was primarily focused for containers. It was known as the container Linux. Now what are the essential benefits of it? So first thing is minimal. So it's a small image. It does not have a lot of packages, because essentially when you are working on production environments, what happens is that you would like to make your environment secure, because there would be user data, there would be data of customers. So you would like to have it more as secure as possible. So reducing the number of having a small OS, what makes it so essentially is made up of smaller number of dependencies. So what because of the smaller number of dependencies, there are less softwares that the uh, folks who would like to exploit your system can exploit. So it essentially in basic terms, it reduces the attack surface area. This is a very common term which is used in security as a attack surface area. And then you have repeatable deployment. So what do you mean by repeatable deployment? If you see my slide, there is this thing as Chef and Puppet. So Chef or Puppet are basically provisioning tools which you use. There are others as well, like Ansible and stuff. But the idea here is like uh, you could those are again a software that you use to write, manage the software to bring up your whole cluster. By cluster I means a group of machines. So suppose you are starting off with your company, you have like 10 users, you probably can do with one server. You grow to 1,000 users, you can probably do with 2000 two servers. But then you slowly grow and grow and grow, and similarly the number of servers that you need would also grow exponentially, linearly, or it totally depends on how your code is written, but it would grow. So now to manage, like, it's easier to manage one server, right? But it might be also easier to manage two server, three server, but at certain point of time it would not be anymore. It would get difficult for you to manage multiple servers. So uh, in that position, in that situation, you have software like Chef, Puppet, Ansible, which comes into place to help you with these kind of deployment solution. But in container Linux, you really don't need a deployment solution. You have a small provisioning tool which we use to spawn those instances. So it's you really don't need those software, so it makes your life more easier. Then you have I hope you understand by file system, like in basic terms, like you have the OS underneath, you have your system working, and underneath there's this file system where you store your files in the basic term. uh, Now in a container Linux, your file system is immutable. That means you cannot change your file system. There is a /usr partition which is made read only. This is because you are restricted to use any restricted from installing any software on the particular machine. And the reason being, the you are provided with a set of packages which is essential to run the container Linux. But then anything you run inside a container, so it provides a jail like environment. A process cannot escape that. It is given the confined space, and you that process only can work inside that particular confined space. Now what happens when you make the file system immutable? So in this situation, there are again it increases the security of the system. There was a security around runc, which essentially never affected Flatcar container Linux. So that's one of the good things. The next thing is automated and streamlined updates. So I know a lot of folks use Linux in your day-to-day life, and update becomes one of the areas where you probably procrastinate a lot. But you should not. You should try to be as updated as possible. Whenever there's an update, be it your desktop system, be it your mobile, always try to install your updates. But in servers, this is more needed, is more essential, because again, like there could be a vulnerability or a CV or a security issue that affects a particular software. And if you don't tackle it, your systems are in for like, what do you say, like are vulnerable or can be affected. So in a container Linux, you have mechanism which easily updates your OS in an automated manner. So whenever there is a OS update, it updates the server. It's similar to like if you have like an Android phone, you might see like there are updates that come on a regular basis whenever the your phone manufacturer sends an update. So it's on the same lines. It also uses almost the same protocol which the Android uses, and it's called the Omaha protocol. And it ensures that your systems are secure. And there is also a system called rollback, because it's possible that system will break during the upgrade. So it is try the whole mechanism of update makes sure, like, if things crashes, it rollbacks to the previous version. So in general, one of the word that you heard a lot was like, one of the main thing you might have understood is the security part. So security is one of the major aspect here. It's even in the in a like the motto of Flatcar container Linux, that is secure by default. So that's comes as the first priority. Like if you're taking a decision, security takes a big uh, I would say it takes the highest priority there. The next thing, it's almost the same thing. I just added a few more picture over there. So just to reiterate, it reduces this attack surface. You have an immutable file system. The idea comes here of principle of least privilege. You have automatic updates, and then you have secure container runtimes. So, how the name flat car come into place? So, flat cars are usually the railway freight wagons that the locomotives carry. So, it's a flatbed that you might have seen in railway stations. So, that's the idea there. From there, the name flat car came into place. Now diving a bit into the Flatcar heritage. So it's a Gen 2 based OS, and I would say it's the bare bones are of Chromium OS or Chrome OS, and the first. So this kinds of come as a heritage from CoreOS Container Linux folks who made this whole OS out of the Chromium OS, and then after Container Linux got went into end of life, it took the Kinfo folks took fork the whole project and build Flatcar containers out of it. And from that time, the Flatcar team and the community has been working on to make it better and better for the whole general community. So yeah, so now is time for the workshop. So I would request all of you to fire your terminals and try to proceed as I go through. If you have any issues, feel free to stop me anywhere, and we can probably discuss it through the you can unmute yourself or directly write in the chat, and we can take it from there. But before moving forward, I would like to ask, like, do you have any questions till now? If you have any questions, you feel free to unmute yourself or type in the chat. Okay, so Aru says no. I'll then start with the workshop. What is reduced attack surface? So attack surface is basically, in simple terms, you can say as there is a question that came privately. So so the question is, what is reduced attack surface? So attack surface is the area where in simple terms, the attack can happen. The attack is basically from the folks who are trying to exploit your system. That can be through n number of ways. That could be through a security issue in a package. That could be through a network issue or something on that lines. And so attack surface is basically comprising through a lot of no, how to say this, through a lot of means. And reducing it means that you try to minimize the number of through which the attack can happen. So it's basically, in other words, you can say the opposite side, it would be like how to increase the security. And once you increase the security, uh, attack surface might not reduce always, but it also possible that if you do, like, suppose for example, you have, and it's really not needed for you to have that in the distribution, but then you had it in the distribution. And then what happened was, there was this security issue that came into picture, came into limelight. You forgot to update your package, and then uh, uh, a person exploited your server through that particular package, and then went on to get all the maybe the user data and leak it on website. So that's is something you really don't want. So that's how the attacks reduce attack surface comes into picture. Do we need to install anything? There are a couple of things that you need to install. I would list it down. It's there on, I have made a small guide, so it's on there, but it's a very minimalistic stuff. But there are a few things you might want to uh, install if it's not present. If you don't want to install stuff, feel free to like just follow through the workshop, see through the stuff. I'll provide with the links. It's there with it's there. There's a workshop uh, guide that I made. It's not fully complete though. There are a few parts which I thought that it might not be possible to finish. Like I might not reach to that point, so I did not create it. But then I would end up updating it. There are Flatcar docs which you can refer, and also The last part would be like I'll pass on the place where the whole Flatcar community communicates, so you can probably join there, and for future if you have any question you can probably follow it from there. How it handles coordination between software running on cluster. Can you elaborate, Anirudh?
Like
Uh,
it has multiple clusters, so each cluster running the Flatcar instance. So the cluster is having the software is running, so how it coordinates the softwares and updates and all these things.
I mean, it depends on totally depends on the way you have done the networking of those clusters. There are multiple ways it can be done. There are various what do you say uh, um, patterns to do so, like probably like maybe like suppose you have a VPC, suppose I'm talking on AWS terms, so you have a suppose a VPC, you create cluster in that, and then you have like people make you can have those private networkings in place, so you have something for web servers, you have for databases. So people have different ways, so there's no one answer to it. It's how you do the setup. For those setup you can refer to the docs, and even suppose if you are working on nets, you can create and then work through. But it's essentially how you set up the whole uh, cluster inside that inside a network, and then it communicates. But usually have the basic IP tools through which you can query and do stuff. If it allows, it allows. If not, then it totally depends on the cluster to cluster. There's no single answer to it. Basically it's just like a normal, there's no difference from running suppose a Ubuntu multi cluster Ubuntu setup or a multi cluster Flatcar setup in that case. Does that answer the question? Okay, cool. Okay, so I'll share my so before I move ahead, I'll share a link here. One minute. So this is the link. Oh no, I shared it privately. Yeah. So this is the link, and if you open up, I'll basically try to do something on the lines where I open the Flatcar docs on one side and follow it through and explain it through as I proceed through. So uh, yeah. 1 minute. Right. Share screen. Okay, my screen is visible, right? Just confirming.
Yeah, it's visible.
Okay, so you can directly open, like change the like my whole desktop theme is dark, and it does not have a way to set the only the website to light theme. So If you open the doc and follow it separately, that's also totally fine, and you might not able to always follow through the screen recording. So that's why it would be better if you can open that link up and follow through that. So yeah, so welcome to the workshop. 1 minute. Yeah. So as I told, like we went through the idea of what Flatcar container is. The idea here would be like to go slow, to go and to cover as much as detail as possible, rather to cover as much as possible. Yeah, so the next thing is probably an empty page, but yeah, moving to concepts. So as I told, like the whole Flatcar ecosystem is built based on Chromium OS, and which again is based on Gen. So you will see the whole package maintenance thing that you see would be from the Gentoo side, and the other part is that in case you are not familiar with the whole Gentoo ecosystem, you might need to dig it up a bit later, but it takes time and there might be a few questions, but feel free to ask them. If it's not possible to cover the whole thing during the span of the workshop, we'll move it to it would be better to ask in the community channel that we have. So yeah, so Gentoo has these packages, and you need to basically, it's not like very traditional. You get the option to customize your packages and do the whole custom installation of your distribution. There's a very niche community of people who use Gentoo, and it's super powerful in terms of distributions. In something I forgot to mention, that in Flatcar you don't get a package manager, so you cannot directly install a package, which again was the principle behind on reducing the attack surface. The next thing is Flatcar. The packages are divided in groups. So you have probably the firewall packages in one section, you have the desktop drivers in one section. I'll show you a demo, and then probably this other packages. Basically they're grouped together, and then you have the package. Within package you have these things called e-build files, and within the e-build files you have all the stuff written on how to fetch the source tarball. Basically you are fetching the actual source from probably GitHub or some uh, uh, other location, and then you have methods to compile it and do installation and then do other stuff with it. This is usually the same for most of the others as well. Like if you go for writing RPM, which is for Fedora, the specs files are almost in the similar manner. You have a way to fetch the source, you then build it, compile it, and then install, move the artifacts that you build through the packages into their own locations and stuff. Yeah, so I'll show you github.com gentoo/gentoo. Yeah, so this is the official repository where the packages are. uh, and if you see the screen, like you have all the groups in here. There are bunch of groups in here, like you can just keep scrolling, there are a bunch of them. And suppose I'll just dig into one. Like suppose I want the last thing I was working was IP table. So net firewall. So you have it in the net firewall, and then you have all the firewall related stuff in here. So you have like the IP tables, and as I told, it will have a e-build file. So IP tables 1.8.7 is the current ongoing one. It has its e-build file in here, and within the e-build file you have like there's this thing called e classes. So the concept of classes, like you can inherit things. So you can have classes, and you can define functions in there, and then you can basically do the reusability part of those. Then you have uh, the dependency mentioned, like this package depends on this stuff. So you have the build dependencies, You have the normal dependency. The B depend is basically the build dependencies. You have the normal dependencies. You have like the run R depend means that it's the runtime dependencies. So this is how you mention at what stage a particular package would be needed, right? So I'll just paste this link. Okay, in the interesting. Jacob, do you know if I can chat as well as share? Is that possible?
Yeah, you can chat
I don't see the chat option. Something.
at the bottom.
Okay, yeah. Got
Yeah.
it. Yeah, so this is the link. Feel free to open this link and for I would say split the window, maybe the Zoom window and this thing, so you can follow through. Uh, just keep it on the side. Yeah, and then you have the patches. So sometimes like you have the packages built for generic softwares, right? So for generic distribution, so there would be things you might not need in your distribution. There might be things that you need in your distribution. So patches are basically like layers of stuff, customized things you can add on top of the existing source of that particular package. Then you have, as I told, there are various functions, like you have src prepare to basically prepare, like when you do cooking, so you gather all the uh, b- uh, ingredients. So similarly you have src prepare, and then configure. So to run the configure, you have the src configure. So similarly you have various methods to handle these things. And you might not see a lot of code, but because of the classes being run, there might be a lot of things happening behind the scenes, because it's uh, you can basically build on stuff. And then you have the install, where like you have things like on how to move a particular, you have the artifacts build, now you have to move things around. So these are essentially, like when you start doing package maintenance, these are a few of the things you will come like these are very common to all most of the distributions. So this is usually how it happens. Suppose if you open up like the fedora distribution and go through its rpm packages and open gentoo one, you might see like how they handle it's almost on the same lines, because at the end of the day uh, the uh, the way the test would always be the same, like you always probably put in slash bin, so things would remain the same. Then you have like package post installation, like things you want to do after things are installed. If you want to set up some variables or set up some configuration files, so those all things happen. So now going ahead, okay, we have a question here. Do we need to learn any particular language like C or Python or Bash? Learning Bash is enough. It depends. Like, see, here you are doing a package maintenance. So if you are, the workshop would be mostly like the best part of getting into like any distribution could be like. It depends on if you're looking from the coding side. It's mostly like it would be adding packages. So in the packages scenario, there are like, if you have Python packages, then it's always best to look through Python ones. If you are good with C, then there would be C packages to look into. Uh, but talking about that, uh, I would say as a beginner, you might not need to learn all of them. Just learning Bash should do. And uh, this whole scenario, in if you're doing like writing e-build file, maintaining e-build file, until unless you go and dig deeper into source, you might not need other languages. Learning Bash should be enough. So yeah, that's answered the questions, right? So yeah, so now that we have seen how the e-builds are, let's move on to the docs again. So uh yeah, so we talked about e-build files, on how they are managed. There are build and runtime dependencies that are needed, and then how we have different functions to do different stuff at different stages. And then we talked about the concept of classes, which allows packaged e-build files to inherit common base functions. Another thing is, you probably I'm not sure how many folks know about this overlays stuff, be it, or you have heard of, like, sorry, so overlay FS kind of a thing. So you basically, overlays are uh, uh you have one layer on top of another. You have a lower layer, you have an upper layer. So in gen 2 terms, you have the gen 2 as the lower layer. You can create a overlay which is a lower layer, and if you want to do customization, you can make on top of that. So in the Flatcar, how Flatcar uses the overlay is that Flatcar uses a fork of Gentoo upstream, which is called portage, and then you have the repository which is called CoreOS overlay. So this essentially builds up the whole thing. And then you have three repositories, which are Flatcar scripts, which is full of bash scripts, which is used to manage the whole image building, image bootstrapping SDKs on top of on which you build and stuff. Then, as I told, you have the portage table, which is kind of is the fork of the gen 2. It has no modification in it and is very close to the gen 2 upstream. And then you have the CoreOS overlay, which has Flatcar specific patches in them, or Flatcar packages in them, which are not there on gen 2. So basically, like, if you see Flatcar, CoreOS overlay is basically top on flat portage, and if anything on the lower is basically overwritten by the upper. Yeah. So moving ahead, so there are tasks. Yeah. So we will dive into this one. The first thing is set up the Flatcar SDK. The Flatcar SDK is basically, you need, as I told, you might be on different systems. I use Fedora in my day-to-day life, and I would need, but I would need a SDK to build Flatcar on top of it. So the first step is to build Flatcar. So given you folks have the yeah so given you folks have the well, so you, as I told, there would be a few system requirements like curl, git, bizip2, gpg, and sudo, which I guess you folks would already have. And so I you don't need anything more than that. Now now you see a section called using Cork. So we have a package called Cork, which essentially manages the whole SDK. So the first thing, we would need to download the Cork. So you can probably copy it and paste it in your terminal. I already have Cork in my system, so I'll skip it, but feel free to, if you're following the workshop. Wait a minute. Okay. So if you're following the workshop, feel free to copy it, or you can just see it through the terminal. Yeah. Okay. So I'll go to workshop. Uh, is my screen font visible? Or should I make it bigger?
Yeah, it's fine now. Yeah.
So so the demo gods never are happy with me, so I have recorded the stuff, but it essentially shows how thing goes, but you can follow through. So yeah, so as you see, I already have the Cork version installed. You can feel free to follow this, and let me know if you have questions. So once you have the Cork installed, you can the best way to is to create a separate SDK directory. So I'll create a workshop directory here, go into it. Okay. Now I am setting on the path of creating the SDK. So if you see here, I have mentioned here a Flatcar 29.05.0.0, which is the latest alpha version that we have released. The idea here is you can use any version like UV publish. There is a SDK for most of the alpha version. We do it for a couple of other if needed for beta as stable as well. But it's always good to use the latest alpha because you have the most of the development packages in there updated, and whatever would be coming through the next releases. We do our development on this. So you can copy it from the doc, and I'll just press enter. So you will see it starts to download the particular SDK. Is downloading the SDK. It's around 1.5 GB. So what happens is that it downloads the SDK, and then it sets the whole ch root up. So basically it creates a ch root, SDK ch root, through which you can interact with the whole Flatcar system. Two ch root during the whole process. One is the image ch root, and other is the SDK ch root. So I'll give some time for folks to like go through this steps. The first step would be to set up Cork, and then to set up the Cork binary. And once the Cork binary is in place, you can just run this particular command, and it should download the SDK for you. I'll go and see. Any questions till now, till the time the SDK is getting downloaded? Any questions? No. So the SDK download is complete, and now it would. So now it's, if you see, it is setting up the whole environment. It would download a couple of things in here. So it will, I'll move this to a different thing. Yeah, so it's essentially, so Flatcar is made up of bunch of other projects as well. So essentially, so there are three of them which are very important, as I told, like CoreOS overlay, Portage, and Flatcar scripts. But then it also have this other packages which is used in the maintenance. So it would clone the whole setup and create the ch root environment for you. It takes a while, but this is a one-time thing. Once it is done, you probably would not have to need to do it and again. So now that you see it's done, I'll do Cork enter, and I'm inside the ch root environment. So this is the environment, the Gentoo environment on which we can do our development. If you see, it dropped me into this repository called scripts. So the script repository is where we do or manage the whole setup. So this is how it would go. So the next thing is So yeah, so now that we have set up the environment, like our like I just want to see a raise of hands, like how many folks are actually following through and how many are just like typing it through, so that I'll wait accordingly. I'll take that answer as like everybody is following. No, or are you folks typing as well? Okay,
Yeah, I think everybody is following.
I guess everyone is following. Yeah. So I'll then go over then at this go over to navigating the SDK. So uh, this is very weird. I'll just stop sharing this. This screen share is weird a bit. Open chat. Oh my god, chat opens. Oh, I can move this finally. Where to put? Yeah. So now so the idea should be clear that we have this SDK up and running. Now the next thing would be like it takes a bit of your time, but it's a one-time thing. Once the SDK is running, the next step is to navigate through see through how the whole SDK looks like. So I'll inside the SDK. So I do cork enter. Now I'm inside the SDK. So the first thing I'll check for is what is the OS. Like traditionally, you might be on a different OS, like be it Fedora, be it Ubuntu, be it Arch, be it maybe Gentoo as well. But if you once you're inside the SDK, you will see that the OS that you're seeing is Flatcar Container Linux. The pretty name is Flatcar Container Linux by Kinfolk, and the version number is 2905.0.0, which is the SDK version that we used. We are good till here. Now the next part is the architecture and setting up the board. So uh, if you deep dive in like operating system, you would have heard of like ARM and ARM based board and other secondary architectures in place, and then you have like AMD boards and stuff. So essentially we have two in here. There are two targets, which are like the AMD 64, which is the general x86, and the other is the ARM 64 that is supported. Right now, like the ARM support is only in Flatcar Alpha, but we are working on that to promote it to the stable releases. Now, the first thing would be to set up the board. I'll just cram that a bit. Yeah. So I'll set up the board, press enter. It does take a bit of a time. So what it does is that it create the directory and sets the whole SDK for AMD 64 based development. If you need to do ARM based development, that you in the flag that I had pasted, uh, this flag, this particular flag, AMD 64, you have to provide it with ARM 64, and it would set up the board for you. So uh, so it will set up the board, and let's wait for it. till the time this is getting set up, I'll go through, like I'll take you a walk through other terminal. Cork enter. Okay, so till the time the setup is happening, let's see through on how things are. So if I do ls here, in scripts, you'll see there are a bunch of different scripts like build packages, build tool chains, build tag release. So anything related to the Flatcar thing, we have a total build library as well. Build library as well, which essentially has all a bunch of Gentoo related stuff, like they have something called catalyst, so that you have more granular updates. So those things are in here. Then, as I talked, you have CoreOS overlay, which is the Flatcar version of the packages. So you have all the CoreOS, the Flatcar specific changes in here, and then you have the porters table, which has the kind of the clone of Gentoo. So these three essentially here we hack around. If you see the logs, you have the package updates happening on a very regular basis to address CVs and sync with the Gentoo upstream. And this happens on a very regular basis. If you move on to CoreOS overlay, you will see a very different kind of log in here. You'll see like a lot of fixes which are very focused towards Flatcar. So you get the idea that CoreOS overlay is for the Flatcar changes. Now, as I talked about, now I'll show you how the setup looks like. So, no, sorry, where yeah, so given the Cox setup was done for a AMD 64 board, so it created a directory called inside the slash build called AMD 64 USR. So this is how when you do the package installation for testing locally, this is where the packages would get installed. So if I go in more deeper, there is this packages folder in there, and if I press tab, you'll see this is where all the package binaries after they have been built, they are placed here. So I'll again take the IP tables example. Hopefully it's there. See, so yeah, so the binaries have been put in here. So whenever you install a package after doing emerge, those installations happens in this particular location. Now moving on to the package, the thing is still happening. So I'll just follow through. So as you see, like this thing does take time. So that's why it's told like we will try to go in depth as possible, because we might not cover them all. And because the whole setup, the initial setup does take probably an hour. Like the whole image building process takes around 30 minutes. After this, when I go through the build packages step, the build packages step takes around an hour or so. So the initial setup takes around 2 to 2.5 hours. And then every time you have to test something, you can do it inside the SDK. But once you are happy with your changes, you can try building an image. The building always takes like around 30 minutes of your time. So that is, as the meme goes, like you can do other stuffs, like my code is compiling, that meme takes over here. So
Sayan, I think we had a question in the chat.
okay, I'll just open up the chat. Okay, good question. So what does manifest branch option means in cork create command? And I have a question which Abrar asked in privately, but he posted now to publicly. So how easy it is to set up on macOS? It is not possible to do it on macOS. The reason is the cork uh, is not built for the binary is not built for that architecture. So you will face you will face issues in that to set up the SDK. So you would need a Linux machine to do the setup. I personally sometimes use a Mac, so in that case, I just um, SSH into a Linux machine and then work it out from there. Okay, now to answer Atharva's question, uh, I'll go to a repo. Info manifest. I'll make it a bit bigger. Yeah, so we have this manifest repo through which you will see here, like you have a couple of versions and stuff in here, right? So this is kind of the metadata, and I'll just go to the alpha 2905 version. So I went to the manifest branch in here. So this is how you switch branches, and the repo is manifest. And inside manifest, you will see this build 2905 XML. You have the OS release, you have release XML, this version.txt. There are a couple of files, and open one of them. And in the build, this build 2905 XML, you have list of the packages that are there with the path where would be installed and the branch to pull or clone. So if you see, when I was talking about three repos, those three repos only have the 2905, which is the portage table scripts, and CoreOS overlay would also have the 2905 ref. Others are all are master. So so basically what happens during cork setup is it essentially queries this particular file, sees what all packages I need to download, and what is the particular branch I need that package to point to. So and it does the setup in that manner. And then you have other wait there are other stuff as well, like you have the Flatcar thing, the OS release thing that I showed, and you have the release XML, which is again the same thing, and the last part is the version.txt, which has the Flatcar version and the SDK version. So basically manifest branch name tells that uh, hey cork, go to the manifest, check the manifest repo. This is the branch name, and just pull the data based on whatever you have in that particular branch name. Is that clear? Yeah, so the SDK, we have like the I'll continue. We have this particular binary. The whole SDK is set up with the AMD 64 binary, so it has pulled all the packages, binary packages, so that you don't need to run stuff every time. The next stuff is building the packages, uh, which is this is when the packages are built. So all the packages in there would be built, the binaries would be created, but this is a very huge task. Like the first setup takes a long time, and it would probably take an hour from here. So whenever I do this, I probably uh, go out and probably pick up another task and try solving those. So but this is how it is. So it's calculating all the dependencies, and it will do complete a bunch of checks, and you will see that at one point of time it might ask that it is emerging some 200 so packages. So it will take some time. So for now I'll just let it run for some time to show you the output, but then I'll kill off this process to show on how the image is built. Okay, so okay, so we were talking about the this setup is hopefully clear, and then we'll move back to scripts. And the next step here is like we will build a Flatcar content image. This would be without any customization. What was it will be basically the changes that are there in the main branch or the alpha, you can say. So uh, so uh, yeah, so you see here like it is showing. So I'll just show you this output a bit. So you are seeing here basically is the packages that will be installed. Binary means it has a binary, but it would be utilizing those binary to install into slash build AMD 64 USR. But if you see the list, it's a huge list. It's not a small list. So it will pick up all the binaries and install them to the board. So till that time, I'll just kill this processor. Okay, so I've killed this one. Now, uh, okay, so I'll just show on how the thing goes. So you have the next step is build image. So you can basically I'll go to this tab where I was showing the binaries. Yeah, so I'll go to the scripts repo, which is scripts, and inside this I told we manage everything. We were here to build the packages as well, like we have build packages in here. We were here to build set up the root, but the last step after the building of the packages is we will build the image. So you can just do build image, enter, and it would again start the process of now the packages are installed inside build in its target. So from target it will start creating a image out of it. And once the image is completed, what we do is that we because Flatcar is there in bunch of other uh, cloud providers as well. So there is a script called image to VM sh, which basically means that it would you can tell like there's a format called QEMU. So if you give QEMU, it will spit out a QEMU image. If you give Azure, it will spit out a image which is compatible with Azure. If you give AWS, it will throw out a AWS format image, and then you can take that image. There are other projects inside the inside the Flatcar ecosystem, which essentially would help you to migrate this whole thing to what do you say, like to the cloud provider. You have the AMIs and stuff. So yeah, so I'll just stop the process, this process here as well. I'll clean because this takes another 30 minutes time to build the whole image. So I'll clean this. I'll directly go I have the stuff ready, so I'll just show you the output of this one. I'll do this, so it will change the format of the latest image that was built. This should be AMD, not ARM, and done. So this is quick. So if you see, it picks up the OEM QEMU OEM, and there's a package called QEMU OEM inside CoreOS overlay, and it installs related packages and does all the OEM setup. So once the setup is done, you can see like the images are created. It's inside this particular folder. So I'll go to this folder. CD src build. Now I'll try to boot the image. Okay, now I am inside this particular folder. I'll boot the image. There is a helper script that is provided. I'll show you in the previous terminal. So if you see here, there are a bunch of files in here. We will essentially use this particular thing and this particular image file. This particular script is the script that would help you spin a QEMU box, and you might need to have the virtualization on. So that is something you might need to check, and the relevant things are there in the doc. So yeah, so I'll quickly go and press enter. The image is booting up, and once the image is booting is complete, once the image booting is complete, you are presented with a shell. So you are essentially inside the Flatcar container Linux OS, and which was built out of that SDK that you had. So you can do stuff. You can SSH into this box from another box and do things, but essentially the machine is done. Now moving ahead, I'll go into a demo of how to add a package. So if you see here, I'll try, there's this thing called NeoFetch. Okay, this was already there. I'll put an older image one. So I have created a bunch of others, like this is the older one, I guess. So I'll just use this one, copy. So like utilizing the time that is booting. So you see, like we use this particular script, the Flatcar QEMU SS script, and booted the image, and you can also SSH through it. But in QEMU we do auto login, so you don't need it. There are some scenarios where you probably need it, so in that scenario you can SSH into the box. The user is core, and by default it runs on 2020 222 port. So let's try this. Is NeoFetch here. So yeah, by traditionally, like if you just pull the box, if you pull uh, fresh SDK and build, you won't have this package called NeoFetch, right? So NeoFetch, you probably, if you shows your in other OS, it will show your OS logo and the metadata associated with it. Flatcar does not ship it, but in this workshop we'll try to add that particular package. Okay, so adding the package to the portage. So as I told, like you can, I'll turn this off, go to the previous one. Okay, I'll now go to the scripts repo. Okay, so by default, uh, the package is right now not there. So how do we approach it? So there is a very simple script called update ebuilds. What it does is that it goes to the gen2 package, gen2 repo that I showed you. It You specify the name and the package you want to fetch, and it would directly clone the particular thing into portage stable, because portage stable is the gen2 clone, right? uh, so let's do that. And you see, it did it quickly. And these are the packages which were copied from the gen2 repo to the portage overlay. So let's go to portage overlay and verify this. So we are in portage stable, in portage stable right now. And if I do git status, you can see that we have the stuff in here. And now we go through the same steps. So now how to install this particular thing. So there's this command called emerge. Emerge is a gen2 based command. And because we are doing customizations, we have done a customization on top of it to maintain that particular set of where to install. Like if you do AMD64, it will do to /build AMD64, if you basically to specify the root directory for it. So if I do emerge enter, it would install the package in /build AMD64 USR. So there is, I have done a recording for that. So let's play the, yeah, so I do cork enter. Uh, then I do, okay, so I go in here, I do ls. This is very weird, this font. I need to, okay, I am in, so by default there's no branch, so you should ideally create a new branch. So here I would create a new branch, and then so you see the in the beginning the new fetch is not there. And the new fetch is not there. It's not, I do an ls, then I move to the scripts. Here I will update the neo fetch. It will clone it. Now let's move, let's immerse the particular file. When you do an emerge, you see here, last time, if you remember, it was called binary because we had it pre-built, but right now it's a new package that we are adding. So it's added n and ebuild. So it will build that particular. Do you like to emerge? Yes. Enter. Now it will pull the source file from the remote repository. It's right now in here. It is pulling from gen2. And once the package is installed, you will see that it installed it in the target, the x86 AMD64 target. Now the next thing would be to build the image. So for that, let's before that, another thing that you would need to do is cd. Now we have installed the package, but it's not associated with the image because we never specified, like there is a CoreOS package, CoreOS base, no, it's not CoreOS. We third-party CoreOS overlay, overlay. Now we are in CoreOS overlay. So there is this package called CoreOS overlay. Sorry, not CoreOS overlay. CoreOS, right? Yeah. So there's just too many CoreOS in there. But anyway, so this is the ebuild file, which essentially is the root image, like whatever is needed in the OS is mentioned in this file. So you will see a bunch of the packages in here. So this is a place where we need to add our package as well. So neo fetch. So we have added neo fetch in here. And the next time we build the image, it will show us the packages getting added. Now we not far, yes.
Sayan, you're on mute.
Sorry, yeah. So this is the pre-built packages that I created. I'll try to see if this has like after the building is complete, everything. So let's quickly Jacob, how much time is left? 2 minutes?
We have 5 minutes.
Okay, so I'll just quickly show the demo and take the final set of questions and slides. Yeah. Sudo power off. Yeah. So the last thing, as I told, like Portage, since it's close, it's a Gen 2 fork. Anything that needs to be patches needs to be added, we need to move it to CoreOS overlay. So we do 290530, and yeah. So this is the image that I pre-built, and I also third party. Okay, before that I would like to show another thing, which was like how to add those patches. So z neo fetch. So we are in the neo fetch. The version number of neo fetch that we are using is git tag, it's 7.1.0. So the ebuild file is 7.1.0, and so we need to go to that particular branch and do the edit. So here, if you see, the patch that I added was adding the Flatcar logo into place, and I created a commit, add Flatcar to neo. It should be neo fetch and not neo patch, but anyways. So and then you can do format here, format patch. What it does is that it spits out a patch file. You can let's see what's inside the patch file. So essentially it gives you the whole commit. Whenever you do any open source contribution, this is something that would always come up. A lot of the projects prefer this style. So now I quickly go to the this CoreOS overlay inside the SDK. So app misc, no, when app misc neo fetch. I told 7.1.0. So let's open the ebuild. And if you see here, I copied the patch inside the SDK. There's a files directory. I'll show you. So so I added this line patches files dir, add new Flatcar new patch, the patch file basically. And let's show you the that file. So inside the app misc neo fetch, there's a files directory. Inside it, we place the patch file, And when it is so what happens is that when it is preparing the source, it would apply the patch on top of your source, and then do the compilation and stuff. So once this whole step is done, you need to repeat the whole step again. You have to do the emerge, and you would not need to do the CoreOS thing. You just simply need to do emerge and then build the image. So once the image is built, again, I'll go to the previously built image, and let's boot this up. Okay, so we have booted. Last time, if you remember, we saw a Tux logo, and let's do it now. And see, given the patch file has been applied successfully, we see a beautiful Flatcar logo instead of the Tux with the Flatcar metadata in place. So yeah, so this is essentially how you uh, um, like the basic steps of package maintenance in Flatcar. This is one of the initial steps. We always encourage folks to do package maintenance in start with package maintenance, and essentially even if you're doing debugging stuff, this is how you would end up interacting with the SDK and the ebuild file. So this is the I would say the bare bones of the whole setup. I'll share. Okay, so I forgot to share one thing. Yes, so last step is adding tests. So we encourage folks to, whenever they have something, you can add tests. There is a YouTube, which one of my YouTube link, or which one of my teammate did on how to add those tests. You can follow that. And if you're looking to contribute, I know like this was like super fast. This is usually a very long workshop, because like the whole setup only takes a good chunk of time, and the image building parts takes another. So my idea was like, if people would have done hands-on, then they could have downloaded the image. But again, like the internet becomes a bottleneck. But feel free to contribute if you want to. We are very active on the Matrix channel. It's linked to IRC, on IRC as well, on the Libera network. The Matrix chat link is app element. You go to app element, and then you join the hash Flatcar. We have users and devs mailing list. If you have questions, you can drop in. The best part of this is the best way to join, I would say, is the community meeting. Join the community meeting, where we discussed, we talk, we take this whole workshop, I would say, in smaller parts. Like we do smaller sections, and over like next 4 to 5 months, we'll complete it as a whole, so that you get more deeper knowledge. And so the next one is on July 13th at 17:30 CST. So it's not IST, it's CST, so it would a bit later time in Indian time zone. And you can find the previous community meeting logs, recordings in this particular link. Talking about the docs is you can browse through the docs. We have how to contribute sections in here as well. And then we have this section as reference. Yeah, we have a developer guide. So you have if you're interested in like OS maintenance, kernel development, and uh, digging deep on how computer works, this is a very good project to work on. And you have like, you can do stuffs in there. So there are a lot of OS based concepts you can learn in here. And the last thing is the issues. So we have a bunch of issues open. So if you want to contribute, like as you can see, like there's a new package request that came in. So so you can directly, like if you're interested, you can just ping us, and you can say like, I would like to take up this as and want to work on it. And this is one of the things which is hugely requested, so feel free to ping us on Matrix channel. And yeah, that's it mostly. uh, and we are a bit over time. If you want to contact me, you feel free to ping me over the Matrix channel. You can also drop me an email. This is my email ID and my Twitter handle. So feel free to contact me over any medium you want.
Yeah, thanks, Sayan. So any quick questions from the audience? And by the way, Sayan, that is a cool photo.
Thanks.
Any quick questions from the audience? You can either post it in the chat or you can unmute yourself. Yeah, so Sayan, so thank you so much. So you've been already part of the panel discussion, and yeah, and the session today regarding the Flatcar container. So I hope it was a great session, and we had a lot of takeaways from that session. So wishing you all the best with your new company, Microsoft. See you again in future workshops. We'll stay connected. Thank you, Sayan. Bye. Take care.
Thanks a lot. Thanks a lot for inviting. Thanks. Bye.
Yeah.
Bye, everyone.
Bye. Yeah, Akshay, can you hear me?
Yes, I can hear you.
Can we just test sharing your screen?
Yeah.
Yeah.
Hey, Sayan, are you there still?
Yes, I'm there, Akshay. How are you?
Yeah. How are things there?
I'm doing good.
Yeah. Nice to hear. In India, right? Back in India.
Yes, yes.
Nice. Can you see my screen?
Yeah, we can see.
Perfect.
So, yeah.
Can I start?
No, we'll just quickly introduce you and then we can start. Yeah,
Okay.
so the next session will be handled by Akshay M. He is actually a research engineer at Free Universität Berlin, Germany. He did his BTech from College of Engineering, Kalupara, in electrical electronics and communication. He has been an exemplary speaker right from his college days, as far as I know. He's also been a IEEE Site Art and Humanitarian Page Contest winner. He was also associated with IC he was a research assistant at IIT Bombay, and he has got a lot of experience in free and open source software, and he has been a technical speaker. So we are really happy, Akshay, to have you here in our midst, and over to you.
Thank you, Jim. Thank you very much. Yes, so thank you very much for inviting me for the session.
Akshay, sorry to interrupt you. I think your video is off.
In my video as well. 1 second. Yeah, can you see me?
Yeah, perfect.
Okay. It should be dark because it's yeah.
Yeah, not a problem.
I think it's okay. Yeah. Okay, so let's start. Yeah, good morning, everyone. I'm happy to be part of Open Source Summit 2021 India. Thank you, Jacob, for the invite, and yeah, and let's start. So this will be an introductory session to RIOT operating system, and this is something which I have been working on for the past 1 year. I've joined the team last year, and the project has been there since last 10 years. So it's a very well-known project in the community. So I'll be discussing more on I'll be starting the discussion on more on what this is and how this could help you create projects for in particular IoT projects. So we'll discuss what this is about, what it is, RIOT OS, some of the key features in RIOT OS, and this is something which is pretty important because I guess most of you might be interested in these features. rather than these key features rather than the operating system itself, which is pretty important as well for in my terms. But I think for most of the audience out here, it matters on what all features do we have, right? Before I move on to the session, I would like to give you some introduction on what is the challenge that we are facing, and what do we how do we plan to tackle it. So there are many phases for IoT, right? So we have the high-end IoT, where we have devices with high computational power of the order of like Raspberry Pis, or it could be a smartphone, which would have a very high-speed computational chip inside, and it could come with all sort of bells and whistles to help you access a very high speed network infrastructure. So it could have a 5G, it could have a wireless LAN, and it comes with big batteries that needs to be charged every day or like 2 days. Whereas when it comes to IoT low end, or what we call as constrained IoT, we have these small tiny MCUs or MPUs, or SOCs, whatever you call it. So these typically come with 8 or 16 or 32-bit architecture. They have memory in order of typically kilobytes, um, and it's supposed to consume very little energy. And the network access could be over LPWAN networks, such as LoRaWAN, or it could be the networks such as BLE, or even Wi-Fi, but on a very limited approach. So why do we call it the challenging class? It's because we are supposed to do a lot, provided we only have several kilobytes of memory. For example, these devices might need a BLE, and it could also need a Wi-Fi, and it could also need LoRaWAN. So all of that has to run in typically say kilobytes of memory. So it could we could only have like say 32 KB of RAM and 1 MB of flash. That's a typical IoT type device that we're talking there. And the device is expected to have say Wi-Fi stack, LoRaWAN stack, and BLE stack, and all of that has to run in a RIOT. It runs in separate threads. It can be managed separately, but still you need memory to manage, and the memory is very limited. And also there is energy constraints. You cannot just eat up the battery in a day. You have the battery supposed, in many cases the batteries are supposed to last for like several years. So the constraints come in terms of mostly in terms of memory, and in terms of what energy that you can consume. And also the IoT landscape today is also something important. I think that is also something that we should discuss. Uh, so if you look at the current industrial approach to IoT, what we have is silos. So we have these silos, by which I mean industrial gateways, which are mostly proprietary ones. So these devices, or the IoT devices, would always talk to these proprietary gateways, and then to the internet. But that is not how internet was built in the first place. If you look at the internet is a very flat network. So you can just have anything. For example, it doesn't matter which kind of Wi-Fi router do you have, right? You can just plug in your router and it should work, and it must work. That's the whole idea of internet, and you should be able to connect to other devices. But when it comes to IoT, this structure is not always visible. So you can see that uh, you get an IoT product from a market, say for example some company with a smart lighting solution. They are expected they I mean the no, they expect you to buy a hub along with it. That hub forms a part of the silo that I discussed just now. So that hub will talk to the internet, and not the device directly talking to the internet. And in most cases, the device is capable of directly talking to the internet. And but the what happens was that the industry, or the company that you might want get the product from, they would build additional features on top of the router, so that you can make use of, like, say for example, some offline application, and so some contextual relevant applications. That is fine. I mean, that is completely fine. The router can always do that. But the problem that they do is that they also do a vendor locking. So these devices can only talk to that particular hub. So, for example, if I get a company, get another company, we're selling like smart fans, and the devices would not be able to talk to that hub. The hub would just be muted. So the thing is, it's fine to build. The idea here is it's fine to build like localized applications based on these routers. It's fine, but the problem is when we have a vendor locking. So the device would just would only be able to talk to the particular hub and not to any other hub, which is not how the internet was supposed to be in the first place. And we are talking about Internet of Things, right? Yes. So, and with that introduction, I would like to start on what is right and how we try to tackle the situation, and how are we trying to solve the situation. Uh, RIOT is, I mean, it's known as, the tagline here is the friendly operating system for IoT. It is known as a friendly operating system because it's similar to Linux. So it has very similar architecture to compare to Linux, and it can run on very constrained devices. So that's the reason why we call the friendly operating system. So similar to Linux, which is a friendly operating system for developers and uh, for security enthusiasts and for the general public and whatnot. Riot is as a friendly operating system for those who want to develop applications for IoT. So when it comes to Riot, it's a microkernel architecture by which I mean we have these modules, and it's not a monolithic structure. So you have a kernel which takes around like 1.5 to 2 KB of memory, and and we can run Riot with just a kernel, but it wouldn't serve a purpose. But the kernel can you can add separate modules. Like for example, if you want like a memory management unit or a sort of for a flash card reader, or maybe say wireless LAN or any of that. Those can be added as modules, and then you also have the application code to interact with the modules. So it's a very modular architecture, and it's a tickless scheduler. But tickless, I mean that it, I mean, it's a very common term that is used in industry, the tickless scheduler. It's in general terms, it means that you don't have a what we call as a timer that periodically fires up to make sure that the execution happens in I mean the concurrent execution happens by switching the threads. So it does not have the timer. So it's a very deterministic event scheduler which does the scheduling, and it happens in real time, and which means you have the thread allocation and execution happens in real time. So uh, this is very important when it comes to Riot, it's a very important feature when it comes to Riot, because a lot of the applications that you see with Riot are expected to be real time. And there is a very interesting hardware abstraction layer and a set of common APIs that allows you to interact with the HAL, uh, and in effect the HAL makes Riot very unique. So for example, if you have say hundreds of boards, you're making like hundreds of products, and you have like very different platforms. It doesn't matter to Riot. So Riot can just have like one single application code, and the hardware abstraction layer takes care of the presentation layer, which is the hardware that we're talking about. Say if you have a nuclear board, if you have a like some other board from a proprietary board from another manufacturer like SparkFun or any of those companies. So they could come with like their own set of different sets of MCUs, different sets of wireless, or it could be wireless SOC or any of that. So the hardware abstraction layer takes care of managing all of that and gives you a common set of APIs. So the application code can work on those platforms with very little change. It has a full IETF network stack support, which is pretty important for any academic professional, because you or researchers, because I mean, you might be doing some research on ICNs and whatnot. And all of the code that you see in GitHub, because the code is available in GitHub, it's all in LGPL 2.1 license, which is pretty important. So many of the companies out there, many of the operating systems that you might have seen using uh, for IoT, they're probably not using a proper free license. It's a must in. I would say this is a very what you call as a Swatandra license, and not what you call as an open license. It's a very Swatandra license. I think this was discussed, the thing about licenses, but the idea here is to make sure that we have a free internet and not like you have like multiple forks and just make the internet more messy. So the roots of Riot, it started off as a spin-off from the 5 Kernel project, and the ancestors of Riot kernel was mostly developed in research projects. So it's still an academic project. So I mean, most of the contribution happens from academia, and you can see that in the commit log, and you can see that in GitHub that a lot of academic research professionals contribute to Riot. We also do have companies contributing to Riot, right? And this, I think we'll discuss that in the later part of the slides. But anyways, so they started off as a 5 Kernel spin-off, and then in 2013, the branding of Riot started. The source code then moved to GitHub, and major development of the network stack and OS as such happened then on. So you can find all of the code in GitHub, all of the commit log, and all of the development cycles. In fact, a new release is happening in upcoming week. So you can see that the feature freeze is supposed to happen in the coming week, and all of that, uh, the community discussions, all of that happens in GitHub. So yeah, so I think the source code being moved to from the SVN repository to the GitHub was a major change, and that has contributed immensely to Riot. I think if it was now, we would have moved to ideally to GitLab, but I think for the time being, this will still be in GitHub because of the kind of users we have in GitHub. Some commercial supporters, yeah, we do have a lot of people who contribute to Riot, and also this could be in terms of like providing hardware or testing out the hardware, or associations, and also contributing to the code upstream. There are several companies doing that, and these are some of the major companies. I think it's easier to find which companies are doing what from the profiles. I mean, what happens is many of these people working in companies, they don't want to endorse a company, so they would just work as an independent, and that is what I have seen so far. And these are the companies uh, which officially endorse, right? And we have a very active and strong community. So we have, I mean, before the corona, we used to have like these monthly meetups, and we also have a yearly summit called Riot Summit, and I think you can learn more about that in the if you can just search for Riot Summit, and you'll see that it's a yearly event where speakers from multitude of I mean, what happens is like we have people coming in from different uh, regions with different skill sets, presenting their experiments with Riot. And also we in many cases we have students coming in with Riot presentations. So in fact, we do usually have people from India coming in with presentations as well. So it's a very common event for, I mean, in the community. It's a very well-known event in the community that every year we have this event. And also we also have monthly hack and acts, which is like we get together. Before the corona, it used to be a physical event where uh, the community used to get together in Hamburg, in Berlin, and in many other places, and we would just tackle a problem and find the solution on the same day. So yes, so it's a very active and strong community, and you can see that in the in the members list and the forums. If you post anything on the forums, you can see that the response is quite immediate, and I don't think any question would take more than 10 minutes to get answered. So it's pretty strong community that we have. And we also have a very efficient hall and a very appealing API, which is pretty subjective. So for me, it's a very appealing API. And if you also get to know the APIs, I think you should also be able to find it very appealing. So it's the idea of Riot is to code once and run it everywhere. So you just code once, which is which by which I mean you just code once the application code, and rest of the hardware dependent code is taken care of by the HAL and the build system. So uh, this is pretty important because uh, the reason one of the reasons why Wright was founded was to promote this idea of code once and flash it everywhere or run everywhere. And this is interesting because many of the competitors for Riot. So if you take any of the real-time operating systems or any of the IoT operating systems, they would have you would need to you would in most cases you would need to write some changes in the hall. And say for example, if you have an 8-bit or a 16-bit architecture, you will have to change some of the function calls as well. So in this case, it's the same API. You don't need to take care of anything on that scale. I mean, whatever the presentation layer gives you, which is hardware, whatever that gives you, is taken care of by the APIs. And we have networking APIs as well, which I'll discuss in the later part of the slides and how it works. So in any case, it's all standard APIs, and we have modular structure. So so if you have like say um, for example, if you have a board like Nucleo, and you want to run the code in it, and you can just specify the board in the make file. Just say board equals Nucleo, say a forward and RE, and you have another Nucleo board. Just say that the board equals say Nucleo X or Y. So it doesn't matter what board you have. It's a small change. This is just a single line change in the uh, make file, and the board will be. You can just build for the board, or you can just pass it as an argument to the makes build system. So, anyways, it's pretty easy to get started with Riot, and it pretty easy to port right to any. I mean, if you write one code, and the same code can pretty easily be ported to any other hardware. And all it matters is a small change in the build system, or a make in the make file. That's it. If at all you want to, you would I mean, of course, if something like, for example, if you have a network like a LoRaWAN or an Ethernet interface, you might need to change uh, the I mean, you might need to call in some modules to manage those interfaces, of course, but you don't need to really change the pinouts, because provided the pinout is standard, provided you might, so for example, if an SPI interface, Riot knows what is a SPI interface and how you would connect the SPI interface with the hardware. So you don't need to specify any pinouts whatsoever in the application code, because all of that is done by the API. Then compliance. So I think this is also very important for any software engineer, any IoT developer. that we have to have the code compliant to certain standards, right? So Riot is compliant with the most common POSIX standard, which is very similar to Linux. And we have POSIX sockets and pthread supports. You don't need, interestingly, you don't need an IoT hardware for debugging Riot. So you can run and debug the Riot as, Riot as an native process in Linux. And by which running, it's pretty straightforward as well. You can just say install Docker on your machine and just call the Docker Riot image, and you can build Riot using the Docker image, and you can run it inside the image, because it can be supported as a native process. So this brings a lot of opportunities. For example, say if you are if you don't have the hardware, you're testing something and you don't have the hardware, you can uh, you can you can, in most cases, you can just run it as a native process. Just define the boards, and you can run it as a native process in your in your machine. And this doesn't mean that you will never need hardware, by the way. The native process can only do, like, for example, very basic stuff. So but if you want something like an interface to an SPI interface, you have an SPI hardware, or, like, for example, you have an I2C hardware, then, or even if you have an RTC, then you have problem. You need a proper board to test, and even that could be done without hardware, without physical hardware, which I'll be talking about later. But in summary, what this means is that you don't need hardware to try out Riot. For you to get started with Riot, you don't need the hardware. You can just uh, clone the repository and have the Riot running as a native process in Linux. Of course, automated testing is crucial, and you might have seen, for those who are familiar with IoT applications and software development for hardware, uh, the testing is very important. And uh, I mean, if you have, like, say, if you do 100 tests, it's good. If you do 1,000 tests, it's better. If you have a hill, it is the best. So what hardware in the loop tests do is, like, uh, in most cases, what we have is, you have platform specific app drivers. And so the what you see in the image is a rack with an ST, I think it's a blue pill board. Yeah, so the blue pill board would act as a what do you call, as a controller to manage uh, the the particular hardware. So you have a blue pill board, and then you have a particular hardware on top of that, and then you can test all of the hardware features. So, for example, you can test the timing of I square C. It can test the timing of, say, SPI or the RTC, or it could check the like, say, for example, LoRa WAN, because if you have two nodes, you can do LoRa, and then there's also gateway nearby, and the Hill takes care of doing that as well. So Hill can do a lot of tests, and it is a very targeted test. So it doesn't mean that Hill is doing the same test for the same hardware repeatedly. It means that Hill means that you have a multitude of hardwares. You have, like, several hardware. This is like what you see out there is the ST chip, the ST blue pill board is not the hardware that we're talking about, by the way. Again, it's a controller which manages the hardware. So you can have these hardware. You can have your hardware board the hill as well. So what I wanted to convey here was that testing is very important, and we do PR per PR. Of course, we do per PR compile test, and that is taken care of by the Markdown CI in the GitHub. Uh, so all of the PRs that one makes before getting merged goes through a Markdown test, and we also have nightly builds which does in hardware testing. And of course, you have GitHub Action support, which means that you can support certain, like cosmetic issues with the code, and, like, all those can be picked up by the GitHub Actions. And also we have like Travis and those kind of CIs to take care of that as well. And then the hill, as I discussed earlier, is it's a very important aspect of Riot. So it makes sure that uh, every release or every commit that you make is goes through a rigorous amount of testing on all of the targets supported by the Riot. So if it's like 200 boards, it makes sure that all of the boards are supported by Riot, the committee supported by Riot. And also it allows for remote testing. So this rack is in Hamburg. It's in top floor in a Hamburg, in a university called Hamburg University of Applied Sciences, Harvey. So there you can also remotely access the rack if required, and uh, if you want to do remote testing, that's also possible. So yeah, we support a lot of testing. We do a lot of testing. Yeah. And yes, the supported hardware so far, we have 200 plus boards, 150 plus drivers. This means sensors, actuators, network devices, and a lot of, I mean, even we have like smartwatches. We have these Wi-Fi ESP8266 space boards. We have microbit, and yeah, so right can even run in Raspberry Pi. If you ask me, you can even run in Raspberry Pi, but we don't endorse that much because right is not intended to be run in Raspberry Pi. You can run in Raspberry Pi as a native process. It's just similar to what or how it runs in your laptop as a native process. You can do that in Raspberry Pi as well, but yeah, we don't endorse that because it's not intended to be run like that. Yeah. So supported hardware, I think most of the hardware out there is supported. So uh, if you look at I mean, even if the hardware is not supported, there is a very good chance that the platform or the architecture is supported. So it's not a big task to just port the hardware, because since the architecture is supported, it's pretty much just mapping the registers and making sure that you have the clock tree is working as intended, and like say we have the peripherals initialized and as intended. So those are like minor nits, and this can be changed in maybe, like for example, if you have a new hardware, there is also a very good chance that the hardware is very similar to an existing hardware. So in fact, I was doing some porting back then. I was doing some porting uh, for a Nordic as chip as I'm joined, and it was very similar to the previous Nordic chip. So we could just clone the entire Nordic chips, the previous one's repository, and then you could make subtle changes, and it works. And that is usually the case. So it's pretty easy to make Riot work in a custom hardware, or even a hardware that is not supported in Riot, provided the architecture is supported. If the architecture is not supported, we have a problem. So but I don't think that is a big issue here, because architectures, I think most of the architecture is supported. So you might not see a risk architecture there yet, because I think we have a risk platform currently. It's a, I think it's a red 5 board. It's being supported currently, but uh, it will probably be an official architecture sometime soon. So yeah, I think then we have all the architectures in the industry supported. So memory requirements. So for a typical Riot situation in for typical hardware, I would say Cortex M0 is the most commonly used controller, and for that particular target, what we have is around 3.2 kbs of ROM and 2.8 kbs of RAM, and this is by far the best utilization memory that you can see in any operating system, for that sake. So if you can just compare with, say for example, like even Zephyr, take the case of Zephyr. So if you can compare it with the Zephyr, uh, a basic RTOS would take a lot more memory and RAM than RAM. And it gets even better. So say if you have 6-low-pan enable, it's just 38.5 kbs of memory and 10 kbs of RAM. This means that you can make RIOT with 6-low-pan working in, say you can have it running in a Arduino board if required. So not a typical Arduino Uno board, the ones which has like enough memory, and you can use 6-low-pan on those. Of course, even though the Arduino, the low-end Arduino boards, you can run RIOT, basic RIOT with basic applications. But yeah, uh, but the 6-low-pan is of course it's a pretty extensive interface, and it's a extensive network layer to handle. So it needs a bit more memory, and but still can make it work in a typical Arduino hardware. So yes, so and if you have JavaScript enabled, yes, it may take a bit more memory, and OT enabled, it probably takes a lot more than basic RIOT OS. Yeah. Programming in RIOT, we support C, and all of that, all of what you see in RIOT as of now is written in C, and we have partial support for C++. Rust is in the development. The API is currently being developed. You can see a lot of activity in the Rust corner in the RIOT forums. A lot of discussions happening. So the current API is in the development process, and it's expected to be out pretty soon. And yes, it has preemptive multi-threading and IPC support, which is very much like Linux. Very much like Linux. Yeah, when it comes to connectivity technologies, these are the technologies that are natively supported by the RIOT stack. So you can, it doesn't, the technologies doesn't limit these technologies. I mean, RIOT does not allow, does not limit you from using any particular technology. You can have your own custom, say, Zigbee or any kind of interface built on top of any of these interfaces. It's completely fine. But by the technologies I mentioned in the slide, but I mean the technologies are natively supported in RIOT. And we have IEEE 802.154, which is a very common IoT standard these days. It's a very common WebPAN. We have BLE, we have NFC, of course, we have Ethernet, we have, and you can run IPv6 over Ethernet, and that's supported in RIOT. We have Wi-Fi, we have CAN bus, we have, of course, we have LoRaWAN, we have cellular technologies currently being worked on. It should be out soon. NB-IoT and LTM, yes, we have support for those. I mean, what happens is these are available as like native, and some of these technologies are also available as packages in RIOT. And it's, I mean, if you say, for example, if you want to have Zigbee in RIOT, so Zigbee usually comes as a like a standard modem, and you can use a standard AT interface in RIOT to communicate with the device. So it's not a big deal to have those devices integrated into RIOT. But these specified technologies, we have our own stacks, and that is pretty important. So for example, LoRaWAN, we have our own LoRaWAN stack, and that is pretty unique to RIOT, because what happens with many of the other competitors, they have a Semtech stack, which obviously we do support as well. So, but what we have is a native stack which we build from ground up. So all of this, what you see is what you have is a native stack, and that we endorse the native stacks, of course. We can have third-party stacks. It's pretty straightforward. You can just have it as a package, import it as a package, and it should work. But these technologies, we have native stacks. And yes, so how do you make RIOT run on system? So I mentioned that RIOT can run on a machine as native, but if you want to use SPI or let's say I2C, since most of these laptops does not support these interfaces, you have a problem. You cannot just test out these interfaces, right? So for that reason, we have these remote testbeds. So RIOT runs on Fit IoT Lab, which is a very common remote testbed, and you can find several tutorials in their website as well as in forums on how to use RIOT with Fit IoT Lab. And in fact, the Fit IoT Lab officially endorsed RIOT. I can see a lot of tutorials. In fact, you can see a lot of workshops as well being conducted by many people using RIOT on Fit Lab. And I've seen many people from India doing this. I hope some of you have at least tried this. It's a very, I think, in these times of COVID, it's very important that we have access to this infrastructure. And this has helped me immensely because I was at some point stuck in India and I could not get any hardware. So most of work, for most of my remote work, I used to depend upon these remote testbeds, and mostly I used to depend on IoT Lab, it supports a lot of radio. In fact, it supports LoRa and LoRaWAN. So most of my work was around LoRaWAN, and it worked fine for me. So I think it will work fine for you as well. If so, the point being made here is RIOT supports Fit IoT Lab, and if you're using Fit IoT Lab, you can uh, just try out RIOT. You can probably say, for example, try out the LoRaWAN application using any of the Sackley nodes available, and you can try using TTN or whatnot. Yes, and now coming to the LoRaWAN support in RIOT. So we have two stacks. One is a GNRC LoRaWAN stack, which is an AT stack developed from scratch, as I mentioned before. And we also have Semtech stack, which is a package imported to RIOT. So Semtech stack is currently based on the LoRa node version 4.4.1 release, which is a pretty old node, but it still works. So GNRC LoRaWAN is a it's an in-house development, in-house implementation of LoRaWAN. It supports LoRaWAN version 1.0.3. It's lightweight and it features ultra low power consumption. It's user friendly. So these are like very generic words, and once you start using RIOT, once you start using GNRC LoRaWAN, you will get to know how lightweight it is. It's pretty much lightweight. When it comes to the memory footprint, I would say it's by far the best implementation that you can find in the network. I mean, in the community. So yes, so then by which low power consumption, I mean low power consumption, by which I mean that so the GNRC LoRaWAN stack being natively developed, it is very interrupt safe. So say your device is in sleep or whatever process that the device is going through, it's interrupt safe, so it doesn't hamper your power cycles or any of the power management routines. So that is very important when it comes to IoT applications. It's user friendly because it respects the standard API. So we'll discuss about GNRC and network APIs later. But what this means is that an application developed for like using GNRC API doesn't I mean doesn't really care about what what presentation layer or what kind of network it is being used, it is using. So for example, you can have the same application for LoRaWAN and BLE, because the application only needs to, in most cases, the application would only need to take care of like making the packet and just transporting the packet. Or say if you have a joining process, just initiate the joining and conclude the joining. So all of that is being taken. I mean, okay, the instructions have to be passed by the application, but the backend code is all being taken care of by the GNRC APIs. That means that it is pretty much possible for you to have the same code for BLE and LoRaWAN applications. So it doesn't matter. So for example, for a new person in RIOT, for a new person, if you are familiar with BLE in RIOT, or if you have used BLE somewhere else, you can just use that knowledge in RIOT to understand the GNRC networking, and you can use the same knowledge to understand same experience to understand how the GNRC LoRaWAN stack works. So that is how user friendly it is. So when it comes to the GNRC network stack, it's a layered architecture. So it's a very what we call as very Linux-like kind of a uh, environment. So you have these APIs which can be like standard APIs. Like for example, if you want to have like IPv6, we have like standard APIs for that. We have UDP, you have standard APIs for that. But you can also have a custom protocol and a custom API implemented if you want. But in most cases, what you have is a presentation layer. For example, in the bottom, what you have is a LoRaWAN that takes care of the giving you a standard set of native interfaces. And once you have native interfaces, it's all about making sure that the application layer can talk to the network native interfaces through this standard set of APIs. So an important aspect to note here is that each protocol would run on its own thread. So for example, if you have LoRaWAN or if you have BLE, all of that would run on separate threads. It's not on the same thread. Okay. And what unifies all of this is a common API, which is a net API. And of course, as mentioned before, this is all customizable. So if you want, and it's very flexible. If you want, say, BLE, LoRaWAN, Ethernet, IEEE 02.15.4, all you can have all of that running on the same device because it's all separate threads. You can have more than one LoRaWAN instance for running because you can simply replicate the thread, and it's pretty scalable in terms of uh, uh, in the interfaces and in terms of the flexibility that you might require at some point. Yeah. The GNRC LoRaWAN interface, as mentioned before, the idea here is that you have, say, for example, you have an application built for LoRaWAN and BLE. You can use the same API for that. It doesn't, the APIs uh, it doesn't care about what kind of course, it's not supposed to care, but that's the case. That's what I'm trying to uh, uh, again enforce here. The idea being enforced here is that uh, you can have the same application, and since APIs do not care about the kind of interface for the kind of network interface that you're using, it's just you can just use APIs, and APIs will do all of the work for you. And it's very unique to RIOT. So we have a unique, as mentioned before, you have a unique interface called GNRC native, and it takes care of managing all of these stacks. So you say if you have LoRaWAN and you have BLE, all of the stack is managed by the GNRC stack. Of course, RIOT doesn't force you to do all of this, by the way. You can just skip the GNRC stack altogether if you want. You can build a custom native interface. All of that can be done, but of course that will be a lot of work. But if you want to get started with RIOT, I suggest you to start using GNRC interfaces, and it's pretty straightforward. So yeah, it gives you results in no time typically. Yeah, some comparisons of what we have so far. So when you compare the GNRC LoRaWAN stack with the Semtech stack, the native stack is not complete because yeah, it is continuously being developed, of course. Um, we don't have all regions supported. So we recently had Indian region supported. We hope to have the European 433 covered in later part of the year. Also, we hope to have more regions, the US region, the Australian region, all of that being covered very shortly. So uh, that's all in the pipeline. The ADR feature is already being tested. You can see PR that it's already being tested. We are waiting for a few changes, and that should be up soon. The ADR by which an adaptive data rate. So Semtech package supports all of these features, at least most of these features, except for native, because Semtech has a very non-generic, which is expected because Semtech doesn't know how GNRC APIs work, of course. So they are not expected to know that, of course. So what that brings is that we'll have to write a separate layer. In most cases, what we have is an adaptation layer, which allows the GNRC stack to connect to the Semtech package, the Semtech stack. Yeah. So it's all pretty documented as well. So if you want to start using, say, start comparing GNRC LoRaWAN and Semtech package, you can always do that by just changing the modules in the make file, and just change. You might need to change a few things with the application code, but it's all well documented because you have two examples in right. One is like example slash GNS LoRaWAN, other is LoRaWAN example slash LoRaWAN. You can compare both of that. There is an extensive documentation on how this works. So it won't take you more than like 1 or 2 hours to arrive at a conclusion on what to use. So if you find that, say, you want to use something in the US region, of course, we don't have any other option but to use Semtech LoRaWAN. But yes, if you want to use it in the Indian region or any of the European region or any of the sub-bands of the European region, you can use the GNRC LoRaWAN stack. So European region, Euro 868 region is also, by the way, it's not just limited to Europe, but when it comes to LoRaWAN, the European EU 868 region is also being used by many other countries. So in fact, IN 868 is a subset of the Euro 868 band. So yeah, so it shouldn't be a problem. So in many cases, you would fall within the boundaries of the Euro 868 region, so it should work. Upcoming LoRaWAN features. So we hope to have Class B, Class C support soon. Adaptive RET already in the pipeline. It's already supposed to happen in the upcoming release. Static header compression, IPv6 over LoWAN. This is a very anticipated feature. We have teams working on it. We will see results pretty soon. More regions, of course. More regions, more people, more contributors. Yes. Deployments. So there have been quite a lot of groundwork in terms of how RIOT can uh, uh, that can be used for industrial applications as well as for hobby projects. So there are these drop patches project which monitors ambient conditions. There is on the bottom right you can see a environmental sensor being mounted on top of a public transport vehicle. And there is a helium balloon project where they try to monitor the it's called the Loon project, mini Loon project, where they try to monitor the environment using a helium balloon and basic embedded hardware. So all of that, these are like very, I would say these are kind of hobby projects. There are also companies that use RIOT. For example, there is Continental, which is a car company. So they make hardware for many of these vendors as well. So I think they make hardware. They do support hardware for Hyundai, Kia, and all of the companies. So they make use of RIOT for their project called OTA keys, where they try to remotely operate the vehicle, remotely open, remotely start. All of that functionality is built on top of RIOT. So also, yeah, we do have many of those, and we also have these companies like companies doing Loca Mesh, which is like a wireless mesh, which allows you to do transport data over like mesh networks, and that's you can find all of that. You can find all of that information in GitHub. I think there is some documentation available in GitHub on how to get to know all of this. Yes. And Jacob, how much time do we have?
As per schedule, we have 1 or 2 more minutes, but it's okay. Maybe you can take another 5 minutes.
Okay, but I have like a, yeah, I can take in, I skip the ICN part, and yeah, I'll go to security features and right, and I'll conclude in another 2 minutes. Yes, so security features on Riot, we do support DTLS, which is currently being implemented as part of Eclipse Tiny DTLS project, and also Wolf's SSL. And we also have crypto primitives like Chacha, which is very AES, Poly 1305. Yes, so right do support crypto primitives to a very extensive degree. In fact, I think it is very unique to Riot that we have lots of these crypto primitives. We have more in the pipeline. We hope to have like lot more coming in soon. And yes, so references, if you want to start off with Riot, I guess obvious way to get started, I guess, is to get started with the website. You can just go to the website, and you can find plenty, uh, lots of information on how to see how to. I can even check if your board is supported in Riot. You can just search in, there's a search tool where you can search, and if you have some board with you, you can just search whether it's supported in Riot or not. Or if it's not supported, there's also documentation on how to make it supported in Riot. That's already there. Then I think GitHub is the best way to get started if you want to do hands-on approach to Riot. So in GitHub, the thing is you have um, lots of documentation available on how to get started, and I think this documentation can point you to how to get started in Riot. And also in Riot, you can find in Riot parent repository there is a section called tutorials. Yeah, this is the tutorial section, and the tutorial section contains step-by-step guide. It contains slides slides and examples, and I mean all of those what you expect from a typical what you call as a classroom session. So all of that is here. So in fact, this tutorial is being used by a few academic institutions for teaching Riot. I think, but it doesn't. I don't think you need a teacher for this. You can get started on your own because all of this is well documented. So, say for example, getting started with Riot, it's like you just clone the repository. Obviously, that is defined in the dependencies. You can search here, just clone the repository. Once you clone the repository, yes, go to the task one, uh, run your first application in Linux as a Linux process, make all term, and yes, that's it. So it's pretty straightforward. So I think all that matters now is like if you are interested in IoT, it's more about exploring the operating systems out there, and Riot gives you an easy way to explore itself. So I mean, I'm not saying that Riot is the best operating system out there. So it does well for certain things. For example, if you want extensive support in LoRaWAN, I think Riot is the best option to go for right now. Uh, and and it takes a lot of time away from you doing the core LoRaWAN stuff. So you can just engage yourself in interfacing sensors, building the application or building the product, rather than uh, taking care of the libraries and all of that. All of that is taken care of by Riot. And compared to, and the question I get a lot is like, I mean, compared to Arduino, I mean, Arduino does the same, right? So, but Arduino does not have, by which I mean, Arduino does not have a uh, uh, I mean, it doesn't have a operating. It is not an operating system. Arduino is just a what we call as a bare metal code. So it doesn't give you the robustness of a microkernel architecture. So, some say for example, if a thread fails, how will the operating system behave? So that, I mean, we don't have threads in on Arduino in the first place. So, but you can use FreeRTOS with Arduino, yes. But still, the threat context switching, all of that, you have to take care of it. But in Riot takes care of it. So it's pretty. I mean, it's a pretty new world for anyone who have tried Arduino. But Arduino is good for starting, I guess. But once you are good with Arduino, I think the natural progression is towards something like Zephyr, Riot, or like previously people used to use Contiki, but I don't think Contiki is not more developed anymore. So then we have FreeRTOS. I think that's a natural progression, and then you make the choice whether you should go for FreeRTOS, Riot, or Zephyr. And I think in that case, that is when in that case you should explore and make a decision. And Riot gives you the option to explore the features in a very user friendly way. So it doesn't give you, I mean, it doesn't take you much time to do that. Yeah, and that's it. I think we can take in some questions now.
Yeah, do we have any questions from the audience? You can unmute yourself or you can ask through the chat window. Akshay, just to know, what are the other similar operating systems available out there?
Uh, for IoT, I think uh, uh, the main operating systems that is in the market, they are FreeRTOS, which is Amazon. I think it's bought by Amazon. So it's a FreeRTOS, and then uh, uh, we have Zephyr, which is a very common operating system, and there are these projects like Tiny OS. I think those are like uh, those have community, but not as large as compared to these three. I mean, I would say Zephyr and Riot are like major competitors, and then we have FreeRTOS. FreeRTOS, you cannot call it an operating system, to be frank, but still people do that. I don't know why, but yeah. So yeah, these three are the major options for the time being, I guess.
Yeah, Akshay, we
Of
have got
course,
some questions in
yeah.
the chat.
Yeah, but of course you can try out. There are several operating systems out there, by the way. But I think when it comes to operating systems, the thing that matters a lot is a community. So how many people are contributing to the code? How many members are there in the GitHub? I mean, that matters a lot. And by this metric, I think these three are the front runners. Yeah.
Yeah, Akshay, we've got some questions in the chat.
Okay. I cannot see the chat for some reason.
Uh, yeah, so I'll read it out for you. So one question is, does Riot support object-oriented programming?
Okay, so Riot has partial CPP support. It doesn't support. I mean, you can write CPP. I mean C++ code, and you can make Riot compile it. It is fine, but it's not really object oriented. And neither is Linux. If you look at it, it's not object oriented. Yeah.
Another question in the chat. Can you tell more about radio frequency modules, RFM modules?
Radio frequency modules. I think it's important that you know how to find this, right? So in Riot, you can go to GitHub Riot, and in drivers. So there are these drivers. So there are like hundreds of drivers here. So uh, so radio modules can come in as a driver, or it can come in as a platform. So typically radio modules come in as a platform because most of the in Riot, most of what we have done is make sure that the evaluation boards are supported. So for example, LoRaWAN, you can in the case of LoRaWAN, I would say in the search for LoRa, and we have ESP32 health tech LoRa module. There is like Feather M0 LoRa, LoRa box, and we also have like the standard modules like BL, I think. Yeah, this is also a LoRaWAN board. So yes, so we have an extensive support for radio modules. Yes.
Yeah, thanks, Akshay. Any more questions from the audience? Yes, so thank you, Akshay. It was a pleasure to have you for the Open Source Summit India 2021, and all the best wishes for your research in Germany. Looking forward to seeing you in future summits, future talks. All the best wishes from the entire team of Open Source Summit. Thank you.
Thank you very much, Jacob. Thank you for the invite.
And as for the participants, we'll resume the session at 1:30 p.m. So we have Harsh Akshit with Linux Kali OS. It's a hands-on workshop. So we'll hope to start by 1:30. So kindly log in by 1:25 p.m. Have a good lunch. Thank you. Bye. Take care. Good afternoon, Akshat. Can you hear me?
Yes, sir, I can hear you. Just let me set up my mic. Just a minute. Huh?
Yeah, sure.
Hello, sir. I hope you can hear me
Yeah,
loud and
perfect.
clear.
Yeah, perfect. So can you just try sharing your screen? Can maybe like a test?
Yeah, just a minute. Huh? Okay, I hope screen is shared right now.
Yeah, I can see your desktop.
So shall we wait for next
Yeah, I think we can wait for another
4 5
five.
minutes?
Yeah, sure, because participants are slowly joining in after the lunch.
Okay, no
Yeah,
problem.
yeah, maybe we can wait for 5 minutes.
Yeah, sure, no problem. I think the
Okay.
other guys will be joining as well.
Yeah, sure. Harsh, I think we can slowly start and maybe people will join soon.
Yeah, sure, sir. So yeah, let me share my
yeah,
screen.
yeah. So meanwhile, I'll just give you an introduction to you.
Yeah.
So welcome to the afternoon session. So today's afternoon session will be a workshop session by Harsh Akshit. He's actually a computer science and engineering student at BITS Misra. He's an experienced member with a lot of history working with computer software industry. And the main thing that I have to tell about Harsh is that he is a Google Hall of Fame. And it is indeed a proud moment for us and all the students out here to be listening to Harsh, who is a Google Hall of Fame. He's also associated with Google Developer Group Ranchi. So it's basically from Ranchi. And he's got immense experience in information security, web application security, and he had been taking numerous workshops from across different parts of India and associated with different educational organizations. So it is my pleasure to welcome Harsh Akshit to this workshop. And a big thank you from the entire team of Open Source Summit for accepting your invitation. Over to you, Harsh.
Thank you, sir. Thanks a lot for such fabulous introduction. And yeah, I'm privileged to be here among you guys.
Yeah, Harsh,
And
sorry to interrupt you. I
mm,
think your
mm.
video is off.
Okay, I need to on my video. Okay.
If you don't mind.
Okay. Actually, I have a setup like I have like a green screen is behind me. Let me if you give me 2 minutes, I can set up that. Or is it fine? Like
Yeah, no problem. No problem. We can have this. No problem.
okay, let me on my camera. Just a minute.
You look perfect.
Just a minute.
Yeah, sure.
If I can add some virtual background, I think there is an option. Okay.
Yeah, I think the blur option is fine.
Hmm.
That's good. Yeah.
Yeah. I think I am visible now.
Yes, you are.
Okay. Thank you. So thank you, sir, for that amazing introduction. So yeah, let me also give a brief introduction about myself. So yeah, so my name is Harsh Akshat, and whatever sir, apart from sir, whatever just said, I've been like into information security. In short, you can say infosec for like past 3 to 4 years. So unofficially, because I've started working in the industry for like from last 1.5 year, you can say. So yeah, before that I used to do like some like I was into learning phase. Still I'm into learning phase, and still I'm learning a lot, teaching a lot. So that's how actually you grow, like when you learn and actually you also uh, share your knowledge with others. So that's the thing. Apart from that, I'm also lead for OWASP Ranchi chapter. I will tell you about what's OWASP. Okay, OWASP Ranchi chapter. So yeah, so other things like sir has already told us. So let's begin with our session. Let me tell you what we'll be doing today. I will giving you like today's agenda. Let's see what's we got in today's bucket, today's agenda. So basically, it's more like a practical hands-on workshop, you can say. So I will give you a brief introduction to web application pen testing, web apps pen testing. Then I will be showing two vulnerabilities that two from the very scratch. You don't need to have any prior knowledge to understand those vulnerabilities. First is SQL injection, and second is going to be IDOR, that is insecure direct object reference, my favorite vulnerability. Uh, IDOR in short, you can tell is at you can call it as insecure direct object reference. Okay. Yeah. Both of them are like very interesting and cool vulnerability. So IDOR, I got a lot of IDORs. Even I have a blog written on payment gateway exploitation that is actually also based on IDOR vulnerability. So we'll be seeing into IDOR right now. And if you want to see anyone, if you want to like see my blog, you can just go to Medium or just search for let's break into payment gateway. Let's break into, yeah. Okay, it's not showing here. Medium. Yeah, so that's my blog on payment gateway exploitation. That's my own research for past what I've did like in past 3-4 years, and this blog received a like very good response. And you can see like it has like all the details from very scratch, from very fundamental. I have told about like what is a payment gateway, how the online transaction actually works, and how actually you can manipulate the online payment. So yeah, I can't show it like live because it's I don't have a demo website for that right now, but actually we are developing with my team at Shape AI. I'm also a cybersecurity lead at Shape AI. Shape AI is a edtech company, so I'm instructor as well as uh, the cybersecurity lead at this Shape AI organization. Okay, I'll be telling you more about Shape AI later. Let's begin with our today's session. So yeah, so let's understand web apps pen testing, and what are the common vulnerabilities out there that you can actually find it like that is, you can say, a low hanging fruit. So if any of you don't know about OWASP, what's OWASP? So OWASP is basically just a minute. Yeah, so basically OWASP is like a open source foundation. So OWASP stands for Open Web Application Security Project. It's a non profit foundation. It's globally recognized foundation. Just like we have IEEE for electronics, there is like uh, ACM for computer science. Just like we have OWASP for security, it's a globally renowned organization. So they have like chapters across the world, and they actually share the knowledge on application security. And I'm like right now leading the Ranchi chapter of this OWASP. Okay, so what they does, they release a list of OWASP top 10 you might have heard of if you are working into security or have a very basic, even a very basic knowledge of security. Then they release a list. Okay, what this list means, the OWASP top 10 is a standard awareness document for developers and web application security. It represents a broad consensus about the most critical security risks to web application. That means what are the vulnerabilities that are very common, and that can be found easily. That's every developer and security practitioner must look upon whenever they are developing a new web application actually. Okay, so they'll release a list of like 10 vulnerabilities. So you can see the first one, that is the injection. There are like many types of injection. So SQL injection, no SQL, LDAP injection, then there is like template injections. So there are actually a lot of injection these days, but back then it was released in 2017. They are like working on 2020 and 21 right now, so they'll will be releasing it anytime soon. So just like we saw, the SQL injection is on number one. Okay, so we'll be looking at the practicals or the hands-on of this SQL injection, how to what's SQL injection, what is SQL, how to perform this SQL injection attack. Okay, and yeah, so it was in 2017, it was on number one, and IDOR, that was in OWASP top 10. OWASP top 10 2007, I guess that was in the list of 2007. IDOR was there. Is it there? Yeah. on the number 4, you can see insecure direct object reference. It was there. It's still like a very commonly found vulnerability. So yeah, but don't know why they remove it from the 2017 list. So yeah, we'll be looking upon these two vulnerabilities. So let's start with the SQL injection. Yeah, first let's understand theoretically. I will try to relate with it with a real world scenario, and I think with that, I think most of you will be like understand it. Like, so sir, can we like interact with the audience if they got any doubt in between?
Yes, sure, you can. No problem.
Okay. So if anyone has any doubt, just put it in the chat. And yeah, so when I will tell you, just you can unmute yourself and ask the question. Okay. So let's start with SQL injection. Okay. So first we'll be starting with SQL injection. Okay. So SQL injection. So if you don't know what's SQL injection, SQL stands for structured query language. It is the language used to interact with the database that is present on the server. So let's stand it like in a more easy way. Yeah. So let's take an example. There is a restaurant. Okay. We are in a restaurant. Okay. We are in a restaurant and there is this table. Okay. One guy is sitting on a table. Okay. Let's say this is me. My name, that's Harsh, sitting on this table. So what are the type of people present in a restaurant? A customer, a chef, a waiter, right? So there is another guy who is waiter. These are the most important person, right? And there is a chef. Okay, this is kitchen, and there is a chef here working in the kitchen. Okay, so he's some cooking something on the gas stove. Okay. Okay, so there is this customer, there is this waiter, there is this guy chef. Okay, so this guy's now the customer actually orders something. So how he will order? He actually calls the waiter. He tells him something. Okay, he tells him something that, yeah, please bring me something like, please bring me pizza and a coke. Okay, that's cold drinks. So please bring me a pizza and a coke. So what the waiter will do? He will go to the he will go to the kitchen. He will tell the chef to please bake a pizza. Okay. So what the chef will do? He will bake the pizza. He will give it to the waiter. I mean, waiter will deliver it to the table, right? Now, similarly, there is the concept the same in the same way the web application is also designed. How? I will tell you right now. So there is three parts how the web application is divided. Okay, the first part you can say the front end, or you can say the client side. Okay, the client side basically us the browser. Okay, the browser, the system where the customer or the user is actually using it. Okay, then there is a server side. Okay, it is also called backend, or you can say server side. Okay, this is the server actually. So server may have like database as well. We represent database like this. Okay, so DB in short, we can we can call database in short DB. Okay, and there must be some medium, right, through which the backend and front end must interact with themselves, right? Without that, web application is incomplete. Whether it's a mobile app like Android application or the iOS application, without that Without the backend server, it's like useless, right? If it is not just a plain or a static web application or mobile application. Okay, so when you want content to be delivered from the server backend, like when you visit Facebook, they like give you like images, the media file, the details that are actually stored on the server, right? That's from where you actually fetch them. How you fetch them? You use actually API. Okay, API. API stands for application programming interface. Programming. Sorry for my handwriting. Absolutely sorry. I know it's very terrible. Interface. Okay. Application programming interface. We call them as API. So now this you can say there is a okay. There is a laptop that we can call as so this is the front end, this is the back end. Okay, this is going to be like some server over here. Let's give it some lights. Okay, okay, this is the server. In that there is also a DB database connected with it. Now who is the customer over here, who is the chef over here, who is the waiter over here? Okay, so this API is actually the waiter guy, this customer is the front end. Okay, this chef is actually the backend or server. Okay, the kitchen where everything is being cooked, right? So that happens actually on the backend where everything is stored. Just like in kitchen you have all the materials to bake the pizza. Such in the such way similar way, the server has all the media files, uh, the details of the customer and everything is stored on the server, right? And actually the details are stored in the database. Okay, now the API that works as a that works actually as a this waiter that brings the request. So what goes here? Here goes the request, and here comes the response from the server. Okay, now whatever this person, this Harsh told this waiter, this he told something, right, to bring him the pizza and coke. That order or query, okay, that order query is done by the SQL. Okay, okay, so SQL. So whatever he said, the words that goes in the form of SQL query in API. Okay, so API carries this SQL query, and SQL query can contain any like please bring me the details of such user or something like that. Okay, we till now any doubt like what's the SQL query, what's API, what's front end, what's back end? Any query till now? Then I will be proceeding. Okay, there is something in the chat. Okay, any query till now? I'm looking into the chat for 1 minute. Okay, I think it's clear till now. If there, just put it in the chat. I'll be keep looking on into it. Okay. Now, what? Let's understand the attack scenario over here. Okay, the SQL injection. Okay. Now, suppose. Let me zoom out a little bit. Let's keep it aside for a while. Okay. Now, suppose there is one more table. There is one more table. Okay, and there is some lady sitting on this table. Okay, there is some lady sitting on this table. Okay, she also ordered something with using this waiter. Okay, and this waiter went to the kitchen and brought the order to her. Okay, now what this guy did, he asked like he asked the waiter that please tell me like what she ordered and what she ordered. Okay, so is this guy actually, he might able to see, but like she is actually sitting like across the dining area. Okay, he won't be able to see that. Okay, so does like this waiter authorized to tell him that what that lady ordered or any other details about her? Absolutely not, because it's her. You can say the order is like, you can say, confidential. Okay, so this guy is like, he is not authorized and he can't tell that, because he might lose his job. So what this person does, okay, what he does, he actually offers him a very good tip. Okay, very good tip to this waiter, that I will give you that this amount of tip, just tell me what he ordered. So either like he knows it, or if in any way she ordered using a different waiter, what he can do, he will go to the kitchen, ask the chef that what that lady on that table number has ordered. Then he can get that details from the chef, right? And he can come back and tell that uh, to the this guy, the bad guy, Harsh. Okay, now like what this guy actually did with this waiter, he actually tried to manipulate this guy, right, using like bribing him, like, or you can say offering him a huge tip. Okay, in similar way you can actually manipulate the SQL query as well, to bring you those data, those information on the server that actually you are not authorized to access. Okay, so will we understanding? Yeah, is anyone speaking? I think someone's mic is on. No one? Okay. Yeah, in similar way, we can do with the SQL query as well. Okay, so let's see how we can perform the attack. Okay, so basically SQL injection is a code injection technique used to execute malicious SQL statement. Okay, so yeah, to understand the attack flow, let's understand the attack flow. Okay, so what happens, there is this guy, he's a bad guy. Okay, now, so suppose there is a login form. Okay, so what's there in a login form? There is first the username, then it asks for a password, and of course there is a submit button. Okay, this is the login form. Login form. Okay, so we are actually trying to check the what where actually the username and password, after we enter it actually gets validated from the database whether the username and password is correct or not. Okay, so it actually utilizes the database. Okay, utilizes, or you can say interacts with database. Okay, so what this guy will do, he will pass some malicious query or malicious keyword in the username field, and he will try to manipulate the SQL query. Okay, so how the SQL query will look? So it will look something like this. Okay, it will look like select star from table, where suppose let's give a username as, give a username as Harsh, and password be 12345. Okay, where user equals to Harsh, and and password equals to 12345. Okay, so this is how the SQL query goes. Okay, in the API carries this SQL query to the backend, to the database, to check whether this SQL query is correct or not. Okay, whether the Harsh is the username Harsh has a password 12345 or not. Okay, so how is like the database is designed? Okay, so there is database. This is database. Okay, inside database there is a table. Okay, there is a table. That table contains in the first column, you can say there is username, and other column there is password. Okay, So in somewhere there would be like a Harsh and similarly the password associated with it. Okay. So inside database, there is this table, and inside table, there is this column, the first column, the second column. Okay. Now, what this SQL query means, select star from table. Okay. First select everything from the table and check whether in that table, username Harsh, in that whether the username Harsh has a password 12345 or not. If it is correct, if it matches, then it is gonna return a true value. Okay, a true value to the front end. Okay, front end, and it is gonna give you the access to the that person's account. Okay, now it is also using a and logic. Okay, and logic. So if you are using a and logic, if you don't know, like when you were in class 11 12, you must have heard read about this and logic, or logic, not logic. So similarly the and how's the truth table looks like. There is basically one x y and the output, right? There is two input and one output, right? So if how's the and logic works, if both of the input is 0, that is false, it is gonna return false. Any of them is actually true, then it's gonna return true. Okay, true, true, true. Okay, this is gonna how the and logic works, right? So it actually works like x multiplied by sorry, x no, x added or logic is added. Okay, yeah. So actually it, sorry, 1 into 0, that's 0 0. So any of the input is false, it's gonna return false. When both of the input is true, then only it's gonna return true. Okay, in our logic, what happens? Definitely there is a one input, one two inputs and one output. Okay, it, in this actually the multiplication happens. So 0 into 0 0, 1 into 0 0, 0 into 0 0, 1 multiplied by 1, that is 1. Okay, so both of the value has to be true. Okay, so this has also to be true, this also has to be true, then only it is gonna return true. But in OR logic, what happens? If any of the value is true, it's gonna return true. So it's 0 0, it returns 0. It's 1 0, it's gonna return 1. It's 0 1, it's gonna return 1, and it's 1 1, it's gonna return 1. Okay, so actually addition happens between the inputs. Okay, so that's why it's gonna return true when there any of the value is true. Okay, I hope you got the or and logic. Okay, so right now the by default it is using and logic. Okay, so let's see how we can actually make up our own query and try to manipulate it. Okay, I think it's clear till now. Yeah, yeah. So this is and logic and this is or logic. Right now and logic, that means both of has to be true. So now let's see how using or logic we can actually manipulate this query. Okay, so now you can see like only two things is under the control of the user, right? That is user and the username and the password. Only these two fields, these two are the things that is under the control of user. So let's like try to manipulate it. Okay, and make our own query, the malicious query actually. Okay, so the malicious query will look something like this. Okay, select star from table. These are not under control. Whatever I'm writing is just the same thing from the earlier one, where user equals to, now here goes our malicious query. Okay, there is also single quote over here. Okay, there is single quote. Okay, to close that single quote, we will be adding one single quote ourselves. Okay, so now this is closed, the user field is actually blank over here. Now we start our query with a single quote. The red one is the single quote. Now it goes like or. Now we are using the or logic over here. Okay, or 1 equals to 1. Now 1 equals to 1 is like true every time, right? We are now actually supplying a true value to the database. Okay, and after that goes a hyphen hyphen. Okay, hyphen hyphen actually used to comment out all the things after that. Okay, after one everything anything after this hyphen hyphen anything is present over there, it is gonna comment out. So now even if this and is present over here, this and is present over here, it is actually commented out. Okay, just like we use the comments in Python or HTML, right? Whatever is the present in the comment section, it is not like that's unexecutable code. Similarly, it becomes unexecutable code. And in password, you can give anything, like you can give 1 2 3 4 5 as well, or leave it blank. It is gonna work, or anything. You can just give anything. Now this part is commented out. Okay, after we did this hyphen hyphen over here. So now it's using the or logic and 1 equals to 1. That is actually true. This is a true value, right? 1 is always equals to 1, right? So we are using the or logic. So here that this, so this is a blank or 1 equals to 1. So this is gonna be false. Okay, but this is true, right? But we are using a or logic over here. So any of the inputs is true, then it's gonna return true, as shown over here. You can see. Okay, so we supplied a true value to the database. It's gonna return us true. That means the database is gonna like permit us and give us the access to that account. Okay, so now this goes into the database. Okay, the malicious query goes into the database. Database is gonna return a true value, and what? So there isn't any user present over here, right? With this blank username and 1 equals to 1 as a password. So there isn't any username. So which user we will be going to get access? Most probably the first in the table. This there is a table, right? So the first user in that table is like we are going to get access to that account. Okay, so who will be the first user to this in this table? uh, According to me, or like it's general, it's going to be the admin user. When you create anything, like the person to do that, to make up those things, is the admin user, right? So similarly, we'll be getting the access to the admin user. Okay, it will returning all every table. Okay, it is gonna return every table from this database, but we are going to get the access to the first user in that table. That is most probably going to be the admin user. Okay, and that's how the attacker gets access to the admin user of this web application. Okay, and now he can actually do anything. The admin user has all the privileges, and he can perform any type of attacks on the database. He can download every database. So we have seen the lot of theory right now. Now let's look into some practical application. Till now, any doubt? Because I'm going to perform this attack using a tool named as SQL map. Okay, I will be using a tool uh, named SQL map. Okay, it's a tool, open source tool. It's a open source tool for SQLi attack. Okay, SQL injection, it's short, it's called SQLi attacks. Okay, so I'll be using this. So any doubt till now? Then I will be proceeding with the practicals. Okay, the hands-on thing. No doubt. Okay, so let's go on and open my Kali machine. Okay, so I'm using a virtual box to host the Kali Linux. Kali Linux is a operating system, and that is actually just for the offensive security purpose. Offensive security means attacking purpose. So if you don't know, like there are different domains of cybersecurity. There is offensive security, there is defensive security, security engineering, malware analysis, and a lot of other domains as well. So this is mostly used for offensive security, also for forensics. So that's the Kali Linux operating system for you. It's a open source, absolutely free. You can go and download it from their website. So let me launch the browser. Yeah, so I'll be using a dummy website, and as you know, like it is a dummy website, so I don't need permission. But if you are performing attack on any live target, and and you don't have the permission, that then you can get yourself in trouble. So uh, like I request you to like do have a permission to perform these type of attacks. Okay, it's a like a very like dangerous attack. Using this, you can actually dump that database as well. There is like a very critical impact on the application who is like vulnerable to SQL injection. Okay, so when I go to this page, this artist and here, okay, so I can see like some parameter is being passed over here. Okay, so now the SQL queries goes in two ways. Using two ways, the SQL query can go from front end to back end. Okay, okay. Let me. Oh, sorry. Yeah. So there are two ways to pass the SQL query to backend. Okay, two ways to pass SQL query. Okay, to backend. Okay, so first is the using the get method. Okay, get method. If you don't know, like these are the HTTPS methods. Okay, so and the second is post method. Okay, in this the query goes in using the URL. The URL you see in the browser. Okay, URL passes the SQL query, and this actually the request body. Okay, here the request body passes or transfers the SQL query. Okay, so now we'll be seeing the example of a get request. Here the SQL query is being passed using the URL, okay, of this application. So here you can see, yeah, anyone wants to speak? No, okay. Yeah, so you can also go and practice on this website. It's testphp.vulnweb.com. Okay, it's the website from Acunetics. Acunetics is a company that actually build tools for security scanning, web vulnerability scanning. Okay, so you can see there is some parameter going on in this URL. There is a parameter artist equals to 1. Okay, now there is parameters such like the in the SQL query we saw that as a parameter there are two parameters were passed in the SQL query. First is the username that has the value the username we supplied, then has the password, that is the second query second parameter. So here also just not we just don't need you to have the username and password to interact with the database. It can be anything that is present on the database. Suppose here the details of an artist is present in the database with the reference this one artist equals to 1. So SQL query is being passed. If we have to check whether the SQL query is being passed or not, and whether this is vulnerable to SQL injection or not. For that, just add single quote and press enter, and it will, you can see it like gave us what SQL error. Okay, there is some error warning from them from the backend from the database. So I think this is going to be like vulnerable to SQL injection, because when we supplied the single quote to this URL, it actually broke the query. And like we like when you pass like when you program and you don't give the proper syntax, it is gonna give you the syntax error, right? Similarly, when we did the single quote, it actually broke down the query, and hence the database gave us this SQL error. Okay, so we know this URL is actually vulnerable to SQL injection. Might be vulnerable. Let's try it and do the attack. Okay, so let's copy this. Open our terminal. So the SQL map is pre-built tool. So just type SQL map and press enter. It will start the SQL map. Just show you the SQL map is present or not. Okay. So here the SQL map is already there in my system. So how to use the SQL map? Just type SQL map space -h, just to show you like what are the arguments we can pass in this SQL map tool. So it can be used in like various different types of SQL injection. So SQL injection is like a very big topic. I'm like taking it in a like in a more precise way. I'm delivering it in a more precise and in a very fundamental way. So there are different type of SQL attacks. So yeah, so I did the -h, that's for help, and we have to use this -u space the URL we have to supply to check for the SQL injection attack. Okay, so let's first clear our screen. So SQL map space -u, that means we are going to supply our -u that URL, control V, control plus shift plus V. Okay, I don't want that. And after that you have to like first what we have to check, we have to actually dump the database. The first thing is the database as a whole, right? So just mention -dbs. Okay, -dbs means database. So it will do the SQL injection attack, and actually it was actually cached in my system, so it did it like very quickly. So what it returned available databases, there is two. First is the ACUART, another is the information schema. So we have to look into actually ACUART, information is schema is not very relevant to us. So now inside database, what was there? There is tables, right? I shown you the tables. There is two columns in the tables. Similarly, there is gonna be table. So let's select a database. So we'll do -d space ACUART, the database, and inside there is table. So mention -- tables. We want to access the tables inside that database. Again, it is cached, so give it like it doesn't take like it takes actually really some time to give you the results. So it's giving you the result because it's already cached in my system. So there is 8 tables present in there. Okay, so according to an attacker, what would be the most relevant table to that attacker? Pictures, I don't think. Guest book, I don't think. Users, definitely. If in every attack, every you can see even recently the Domino's, and even I heard like LinkedIn database got labeled, and every time they actually targets the users database. Okay, because there is a lot of information present in the users database that can be used in a like very malicious way. I don't want to say that. Don't want to go deep into that. So yeah, so now let's select a table. So -t and the table users. Okay, and let's press enter. Oh, sorry, I forgot to give users, and inside the table there is column. So mention -columns columns. Now it will show all the columns present inside the tables, inside the user table. Inside there, there is this email CC. You can see all the details that is actually present in the database is being displayed over here. Name, password, phone, uname. So I want to know the username and the password. So I will select -c space. I want to know the name, password, and username, that is uname in short. And what else? Let's take also the phone. Okay, phone, and hyphen dump to dump the database. Okay, we'll start attacking. Okay, so it's shown the name, the password, that is test, uname test, phone number over here. So that database, we got the access to the database using the SQL injection. So we did the SQL injection using the tool. You can also do it manually. So for that, you must have the knowledge of SQL. If not, you can use the SQL map tool. Okay. So sorry, not this one. Yeah. So when we go to our browser and go to like login, sign up here, it is already mentioned the test, and test is the usernames. So, but yeah, we got the test right using the SQL injection attack. Just let's do it, and it will give access. Yeah, so we just logged in as a test account. Okay, so that was the SQL injection attack. You can also try to do it with yourself as well with your own system. So yeah, so that was SQL injection attack, the theoretical part as well. Now, if you have a doubt, just ask me, or I will be moving on to other vulnerability. Any doubt? Like I'll be taking the doubts till next 2 minutes. No doubt. You can also unmute yourself. Don't hesitate to ask any doubt.
Participants, feel free to unmute. You can drop your questions in the chat box.
Yeah, just don't hesitate. Like even a lame doubt can be like it can be not just for you, for anyone. Like even I ask sometimes very lame doubts, I don't want to say it will like embarrass me, so just ask me like if you got any doubt. Even a very simple, very basic one will work, don't worry.
Harsh, I think we've got some questions now.
Okay, sir, what if the DBMS doesn't respond to the attack? Yeah, definitely. Like there isn't any firewall or any protection with this website, right? Because it's a dummy website just to showcase this SQL injection attack. Yeah, there can be preventive measures. There can be like DBM, like there can be firewall that will block the malicious query, and what else? Yeah, they will be like taking whatever the input is being supplied by the user. It will be supplied as a string data type, so that won't get validated or won't be like won't like the database won't run that queries. Okay, so yeah, that's the thing. That's there are preventive measures.
Questions.
Okay, how to bypass firewall? Okay, there are many way. Okay, there are like what the firewall does, they actually blocks some like very common or very well known SQL query, malicious SQL query actually. So that's why you need like the SQL knowledge of SQL to make your own query, try to bypass the firewall using like different type of queries. Okay, so that's the way you can use like you must read OWASP preventive measures for SQL injection. Okay, let me show you quickly. OWASP SQLI prevention, there is a cheat sheet. Yeah, so you must read this. This is a documentation by OWASP. So this is what the developers or even the attackers look upon to see if they can bypass using these techniques. Okay, so here the preventive measures are mentioned over here. Just do the opposite while attacking and see if your attack works. That can help you to like bypass the firewall, or if there is like whitelisting of the SQL query. Okay, they also whitelist only certain type of SQL query. Other than that, won't be validated or won't be run by the database. Okay, so that's the way. I hope you got your answer. Oh, thank you, sir. Okay. What is blind SQL injection? Okay, so blind SQL injection is like I said, like there is like union attacks, there is like blind SQL injection attack. So similarly, like there is many type of attacks. So blind SQL injection, um, where suppose we what we did in the URL, we supplied a single code to check whether there is a blind SQL, where there is a SQL injection or not. In many cases, it doesn't throw us the error. In that case, how we will be knowing like there is SQL injection or not? So we blindly actually supplies the malicious query and check whether we get the response from the database or not. So in that, like if you know like what is blind XSS attack, any of you know like what's Melvin, Daniel, like do you know like what's blind XSS attack? In that, like you just supply some that is XSS attack is used to steal the cookies actually. Okay, yes, you know. So in the similar way, we don't know like whether SQL injection is like present or not, and we just throw our malicious query to get something from the database. If you get like, then there is a there is a blind SQL injection attack. Okay, I hope you got your answer. Let's move on with our. I think there is want to be any more question. So let's move on with our next vulnerability. Okay. Okay. Now again, let's look upon the. Okay. Now let's look upon the IDOR vulnerability that is actually my favorite, personal favorite as well. So IDOR. So insecure direct object reference. Okay. In short, we call it as IDOR. The logic is very simple with this vulnerability, and I don't know like still why this vulnerability exists or why it is like very commonly found out there. Okay, so going on, like what happens in this vulnerability is that the application actually directly exposes a reference to an object, okay, just using the user supplied inputs. Okay, let me give you a very like very short example. Suppose there is this our website shapeai.tech. Okay, I have logged in as a user. Okay, so the URL looks something like that. This okay, view user info. Okay, where user equals to like my name is like user equals to 1. Okay, and what this URL displays? This URL displays like my name. Let me use other ink. Okay, my name, my email, my phone number. Okay, and my picture, and like whatever you find in your profile details. Okay, so you know like the email and phone number, this is sometimes confidential. Okay, confidential, and it like you shouldn't like expose your phone number and email like anything any other thing on internet. So you know this is a confidential thing, you can take it as a confidential thing, and this is the URL using which we are actually accessing these all details. And we are actually accessing these details because we are actually logged in as user 1. Okay, we are logged in as user 1. Now you saw that this URL has some parameter. We are all now again playing with the parameter. We played with the parameter earlier as well. Again, we are doing the same thing. Okay. Now, suppose what you saw that there is some parameter that has user and equals to 1. You changed it and made it 2. Okay. Suppose it has my name. It has my email, my phone number, my picture. As soon as I change it to 2, the details also changed. Okay, now it shows any other name. Okay, let's use my second name, that is Akshay, and this is another guy. Okay, this is the first guy, this is the second guy. Okay, so yeah, so now it exposes the email of this Akshay, the phone number of Akshay, the picture of Akshay. Okay, do you think that just by changing the parameter in the URL, the application should have just displayed the information of other user just so simply? Huh? I don't think so, because that is a type of information disclosure and you are just changing the parameter in the URL. And this is actually the logic. Okay, so you are changing the parameter and it is giving the access or directly exposes, okay, exposes a reference to an object. Okay, that what it means. Okay, exposes a reference to an object. Okay, so that's insecure direct object reference, that's the vulnerability behind it. Okay, and it can be like this IDOR can present anywhere in the URL, in the API, and many, like I can't say many places. Even my blog that says based upon the payment gateway issue, the payment gateway vulnerability, and that is also a kind of a IDOR vulnerability. Okay, we are also play in the request and response of the payment gateway and play with the like the values or the parameters present in them. Okay, so now what happens? Let's get back again to that restaurant, and I think you already understood the restaurant and that API thing, right? You actually related with that, like how the API works and how that waiter in the restaurant works. Okay, now suppose again there is a front end, or you can say let's take client side. There is a server side. Okay, now there is a API that carries the request and response. Here goes the request. You can see the request and response using a tool known as Burp Suite. It's very widely used tool. It's okay, Burp Suite. It's available in pro version and community version. Community version is free, and like you can like get it for free from their website. It is like it's costly, it's $399. Okay, so most of you can't afford it, but you can use the community version and you can perform the attacks like SQL injection and this IDOR vulnerability using the community version as well. Okay, so here this is the API, right? The one that carrying the request and the response from client side and the server side. So similarly, so in the request, there might be going some parameters like uh, the user ID, the user, that is one, the name doesn't, right? The name and those comes from the server. Okay, so you are just supplying the user equals to one using this request. So it return when user one, it actually return the name, that is Harsh, and all the details like phone number, email, on all the things. Okay, but when I did it, like made it 2, okay, user equals to 2, it came back with other details, that is the name equals to Akshit. Okay, so you can also do it in the URL, you can also do it in the request. Sometimes in the request you may find this type of parameters and try to change it, try to play with it. Okay, and you may get some details that is actually not intended to show to you, but it does. And that's how the IDOR vulnerability works. Okay, so it can be present in the API, it can be present in the URL, it can be present on the client side, anywhere. Okay, so you just have to play with the parameters. Anywhere you find parameters, just try to change the value. Okay, So yeah, so I hope the IDOR vulnerability is clear. That is the only the basic logic behind the IDOR vulnerability. Anything till now, because I'll be then jumping into the practical part. Okay, for that I'll be using CTF designed by Hacker 101, Hacker 1. Let me quickly create a account in Hacker 101 using a temp mail. Okay, this is a temporary mail you can use to avoid getting spammed on any website that is asking for uh, your email address. Okay. Okay, get started now. Till then, you can think of any doubt you have till now, and I will be answering that. And then till then I will be creating the account really quick. It won't take much time. So HackerOne is a bug bounty platform. If you know what's bug bounty, where you can submit a bug, okay, where you can submit a bug and get paid for it if the bug is valid and not duplicate. Okay.
Yeah, Harsh, I think
Yeah.
we've got one question in the chat.
Yeah, let me like complete it and I will be
Sure.
answering that. Okay. Okay, I need to verify it now. I'll be getting the verification mail. Yeah, here is the verification mail. Okay, I think I just created the account. Let's log in. Okay, why? Okay, it's asking for the email address. Okay, our account has been created. Okay, are there is it better used to use virtual machine for hacking? Is it better to use? Okay, you are right now. Most of you, I think, it would be the beginner, right? Most of you are beginners, so you can start with the virtual machine. Okay, then if you think like, yeah, you want to go further and do it like on a more scale, like a more larger scale, you must go with like dual booting your system. Okay, dual booting, like with dual boot actually you can keep two operating system. Either you can boot into your Windows machine or you can boot into your Kali Linux. So I have dual boot, as well as when I want to show any demo or something like that, I use the virtual machine. Okay. Okay, sir, in cloud, our work can be hacked by anyone. Okay, cloud is another thing. They use the sandboxing technique. If you don't know what sandboxing is, but yeah, cloud is going to be like more secure, you can say. But yeah, everything on internet or that is virtual got its own vulnerability. But no, it's not really that your work can be hacked. Okay, you can store your information over there as well. Any more question? I would just give a tip to every one of you, like if anyone is in security domain, or like going to start your career in security domain, like I have been like through various uh, interviews, that is on for security roles. So even I interviewed for Google North America for security engineer this year in the month of February. And like each and every one of them, like they asked me like how much you know about cloud and how much you have the knowledge about cloud security. So I would say that you just focus on cloud and cloud security, and if possible go for the AWS, because most that is the most widely used, AWS. So yeah, so I would say that more focus on cloud, it's going to like add a lot of value to your profile. Okay, I think I have answered both of your question. Anything else? Okay, then let me continue. So there is a CTF challenge present in Hacker 101. This is postbook. Okay, that is just based on like it's a clone of you can say Facebook, and it is based on real scenario of IDOR vulnerability that existed earlier, but now they have been fixed, and then they created a clone of it and the vulnerability with it. Okay, so let it launch. Sometimes actually they don't use like, don't know, the main hacker one domain and server is I think different, and they use a different domain and server for this CTF, and they don't really much invest in that. So sometimes it even like breaks down, goes down. So let's see if it is working or not. Okay. So this postbook challenge is completely based, mostly like I think most of the challenges is based on IDOR vulnerabilities, and it will show you like how differently you can exploit this IDOR vulnerability. So let it start, and till then, if anyone got any more questions, just put it in the chat. I'm also looking into the chat right now. Till then, it's when it till then up to then when it is launching. Let me tell you about the Shape AI, okay, where I'm working right now. Okay. So this is a edtech educational technology company. Okay, I'm working as a cybersecurity lead. I also give like I conduct boot camps. So boot camp is like 7 day totally completely free classes where we teach kids like people over YouTube. Okay, so for that you can like the upcoming boot camp details will be updated on the shapeai.tech channel. Okay, on this website, and the bootcamp will be live on this YouTube channel of Shape AI. Okay, so yeah, this is the Shape AI's YouTube channel with 86K subscriber. We also have one more, but this is the main channel. So you can register for the boot camp, and when like the details will be updated. So now the boot camp is already running. One boot camp is already running, and we'll be starting with the next boot camp. Okay, so right now the Python and network security is already going on. We'll be doing the completely attack based boot camp from I think the second week or the first week of July. Okay, keep looking on this website to get the details. Okay, so I think there is some noise from someone. Okay, so that's Shape AI, and yeah. Also, we are launching courses. If you are interested, you can look into this letter. Okay, we are also launching course on cybersecurity training and internship program. That is a job ready course. You can look into that if you are interested. Okay, and yeah. So let's see if it's launching or not. What's happening? You can also try it at hacker101.com. Okay, You must also try. There are many other challenges as well. There is also challenges based on SQL injection. Okay, so it's hacker101.com. Okay, so this is the CTF actually. Okay, what's CTF? If you don't know, CTF stands for capture the flag. Okay, capture the flag. Okay, so just like how we practice coding, we just participate in hackathon, we do code chef, we practice on code chef or hacker rank, right? So similarly we have built like this CTF, some CTFs that helps you to like enhance your knowledge, to practice your concepts in security. So there are other CTF as well. If you are a very beginner, you can go with Pico CTF. This is very beginner friendly. You can start your journey with Pico CTF, then go on to the HackerOne CTF. And if you think you are really pro with the CTF thing, you can jump into Hack the Box. Okay, Hack the Box. It is freemium service. You get some free as well as it is also premium. Like you have to pay for some machines, so it's freemium. And these two are completely free. Okay, so you can just learn as well as practice over there. Okay, in that our course we have also just mentioned a separate section just for practicing, just to demonstrate or just to show you like how to solve the CTFs. Okay, so in CTF you use real tools that are involved in hacking. So yeah, so that's the benefit of CTF, playing CTF to enhance your knowledge. Any doubt till now? I don't know what's happening. Why is it not launching? If you guys like, even if you guys got any query, whatever I taught today, whatever I shown you today, I also, sir, can I like share my number with them? Is it like permittable
Yeah,
to
it's
share my
okay.
number?
Yeah,
Okay.
sure, no problem.
Okay, so my number goes on like that's the country. If any of you from outside India, that's the country code for India, and my number is 86960 44422. If you got any query like about this, whatever I like shown you today, any query regarding uh, the course or bootcamp at ShapeAI, you can just text me. Okay, please no calls because I don't take calls usually. WhatsApp me. Okay, and yeah, I will be responding to your WhatsApp text. Okay, so yeah, I think there is some question in the chat. What would you recommend newbies to start with CTF? Definitely go with the Pico CTF. I told you, right? The Pico CTF, the second one. It's really beginner friendly, and yeah, you can go with the Pico CTF. That's the any beginner should start with. Okay, there is one more query, and it actually covers all the aspect like reverse engineering, web attacks, forensics, cryptography. All has been there. Like cryptography is like one other domain that involves a lot of mathematics for the encryption purpose. So like what's the difference between HTTP and HTTPS? HTTP and HTTPS. Okay, S for here is actually stands for secured. Okay, secured. That means whatever your data is being passed over internet, under this HTTPS protocol, it is being encrypted. Okay, the data is being passed and it is present in unreadable format. That is the data has been converted into, like, if you're sending your username and password, it is going into some gibberish text, or you can say cipher text, something like random, anything like the alphabets, numbers, anything. But under the HTTP protocol, the details or the information is being passed under clear text. The username password goes in the clear text. Okay, anyone can see in whoever is present on the same network you are using, anyone can see the username and password. Okay, so many of you have like the issue like many of them like ask me what's the HTTP and HTTPS, and is it secure to use HTTP if it is not having like HTTPS protocol. You can use the HTTP protocol if you are not sending any like confidential information like username, password, or any what other any like confidential details. Okay, so in that case you don't use like the HTTP protocol. What is SSL? Yeah, using the SSL we actually do the SSL stands for secure socket layer. SSL stands for secure socket layer. Okay, this is a transport layer security. Okay, you must have heard about TLS, transport layer security. So SSL is actually being implemented on the transport layer, and that actually converts the HTTP to HTTPS. Okay, so that's what actually makes the encryption, that actually creates the encryption between the client and the server. Okay, so yeah, that's the thing in brief. I would say if you got the thing, if you understood it, that then it's fine. So whatever goes here, okay, here it goes unencrypted. But in HTTPS, if there is no SSL certificate present, then it goes unencrypted. Okay, unencrypted, encrypted, clear text. Let's see if our CTF is working or not. I think it again like not working, crashed. It's not taking. Why? Actually, it happened once. I will ask my team to create the copy of this so it doesn't crash anytime like I show the demo. I think it's not working. We are actually working on like creating our own labs on ShapeAI, so that we don't have to be dependent on other resources. So yeah, hope you got the answer for the SSL. Who was it? Jeff Thomas. I hope you got your answers, Jeff. SSL
Yes.
involves, yeah, okay. So involves a lot of encryption. You have to, if you want to work on this transport layer security, then you must go and pursue it as well. But you need to know a lot of maths. Right now, the HTTP 1.1 is being used. Now HTTP 2.0 will be launching soon. Still, they are working on it, and like there are many universities involved in like developing the HTTP 2.0. It's still like it's actually present on internet, but actually it's like you can say a beta form of that. Okay, so I'm really sorry, I don't know, like this isn't working. It's just showing the level is setting up. Okay, I think it's not my error. Yeah, the host, like they are down, you can see my browser is working fine, everything is working fine, just they are down. I'm really sorry about that. uh if you want to see that, I can share a link. I've also shown the same thing in my bootcamp at ShapeAI. You can just go to the YouTube channel, and in that you can see like Python and cybersecurity bootcamp. In that you will be finding it in day 5. Okay, Python and cybersecurity bootcamp day 5. You will finding the IDOR demonstration. Okay, on this same CTF. Okay, I hope there is one more question. Which cryptographic algorithm is more secured, sir? Okay, I don't want to get more into cryptography because it's really complicated thing. There is no such thing like the more secure cryptographic algorithm. Okay, actually, the cryptography is based on if uh, there is key sharing that happens between the client and the server. Okay, let me open my board once again. Whiteboard. Actually, it's black and the name is whiteboard. So there is actually key exchange happens. Okay, in cryptography, Actually, key exchange happens between the client and the server. Okay. There are two type of key. One is symmetric key, and second is asymmetric key. Okay. Here the client and server has the same key, and the asymmetric key have different key. The client and server has different key. Okay. Okay, I think there is something more in the chat. Let me see. Can stored procedures really prevent SQL injection? I don't got your question, Nikila. If you can, like, you can try to unmute yourself and ask the question. Okay, I think she can't. She or he, I don't know, can't hear me. Okay, no worries. If you can hear me, then just I think I didn't get your question. Can stored procedures really prevent what stored procedures? I don't really get you. Okay, let me give you like the brief introduction to this cryptography, the asymmetric and symmetric key. Okay, suppose this is me. Okay, this is me at home. I want to send letter. So this is Harsh, and there is one more guy. This is Akshat. Okay, I want to send a letter to from I want like me Harsh want to send a letter to Akshat. Okay, and I just write a letter and like it add it in an envelope and send it to Akshat. Okay, now in between that, you know, the letter has been written in clear text and that is inside this envelope. Okay, and now it goes on to the hand of the post office. It goes to post office, then it goes to another post office, destination post office. Okay, then it again goes to the hand in the hand of the postman. Okay, I think Dr. Akhilesh Kumar, you are writing on my white pad. Okay, the on the hands of I think you are mistakenly writing on my white blackboard. Okay, yeah. So post office, then post office, again the postman, and you know, like anyone can just open the envelope and read your letter, right? Whether the any person at this post office or this post office or even the postman can read your letter. Okay, and finally it arrives here at to this guy at whose name is Akshay. You know, this is the unsecure way of delivering your message, right? So you can use, suppose this is the HTTP method. Okay, HTTP method. Let's see what happens in HTTPS method. Okay, so now what you did, you the envelope, you actually kept it inside a box. Okay, inside a box, and the box is locked. Okay, the box is actually locked with a padlock. Okay, you kept this letter, the envelope, inside a box and locked it. Okay, and you have a key. Okay, you have a key with you. One key is with you and another copy of the key, same key, is with Akshat. Okay, okay, one key is with me, one key is one key is with the person, that is Akshat. Okay, now you give this box to post office. Will the post office will be any guy or any person at post office will be able to see what's inside that box or what's inside, like what's written in the message? Definitely not, because it's logged and the key is with you. Another key is with the person at the destination. It goes to the destination post office. It again, the person at the destination post office can't see that. Again, the postman not able to see that. Finally it arrives at this place, the same box. Okay, okay, now he uses the key and opens this box. Okay, and now he can see the letter, whatever the letter is there, whatever the message, and extra security as a form of this box. Okay, and we have a key. over here and over here. So that's the key, the same key, symmetric key. And there is a different, this is also called private key, and this is called public key. Public key cryptography. Okay. Okay, and this is private key cryptography. I won't go much into details, but it will only just go and confuse you. Okay. So yeah, so we added an extra layer of security using this box, and that's what happens with the SSL certificate. It actually makes the message into unreadable format while being transferred using whatever method you are using, okay, in the network. So I hope I was able to make you understand this basics of cryptography. So like there isn't any like such thing like what is the most secure algorithm. The key and those things, the mathematical functions you are using to encrypt this, that's what makes it stronger. Okay, a lot of mathematics is involved in this cryptography. And if you are preparing for the security engineer role, you must have like knowledge of all the domains. Okay, whether it's cryptography, whether it's a web application, web application, you must know any one programming language like Python. In my Google's interview, they asked about Python or Go. Go is actually developed by Google. Go is a language developed by Google. They asked me like various server security, network security, and I don't remember more than that. Yeah. So you must expect the question from very wide domain. Okay. So yeah, that's the thing. If you like look over internet, what are the question being asked in the security engineers interview, you will get a lot of results. Okay. I hope I was able to make you understand this. Again, if you had any query in future regarding anything, whatever I taught you today, or any question regarding the boot camps or courses, you can reach out to me on this number. Okay. So yeah, that would be it. That would be all. I hope I'm really sorry this application didn't work, and I won't be able to. Unfortunately, I won't be able to show you the practicals of IDOR. If it works right now, but we are not left with much time. Still, it's not launching. Anyways, you can find the same thing. Okay, it launched. Okay, that's great. So sign in. So there are actually flags. Okay, let me quickly show you some flags, how to find the flags. Okay, you will get the points after you find any flags. Okay, you go to hints. So I know, like, I have solved it many times. I know how to find the flags, but I will show you. Like, let's go with the first hint, flag 0. So the person with username user has a very easy password. Okay, so the username is user and the password is very easy. So what could be the password? Any idea? The password is very easy. Any idea? Anyone in the audience? Write it in the chat. Username is user. User password. Let's try both of them. Let's try with user. Is it working? Okay, you entered a wrong password. Okay, let's try with password. Okay, and I think password is gonna work. Okay, submit this. Yeah, and you can see we got our first flag. So to get the points, just copy this, go here, submit flag, add the flag over here, and check whether the flag is valid or not. Yeah, the flag is valid. Congratulations, you found a flag. Okay. So let me, like I just told you about the cryptography thing. Okay, and also told you about the IDOR thing. Let's tell you, like, let's make you go through the both of the concept at the same time. You know, the cookies are stored over here, right? In this if you know, the cookies are stored in your browser. Don't know, I'm using the incognito whether they are storing my cookies or not. Let's go over here. Okay, they are storing my cookies. You can see the cookie, the parameter is ID, and there is some value, but the value is actually gibberish. It is an unreadable format, right? Actually, it is encrypted. Let's copy this. And there is some tools present online to actually crack those things, crack those hashes. First is Crack Station. Okay, very widely used tool. Okay, just copy this. Okay, and crack this. What's the readable form? Okay, so it is a MD5 type of this is the algorithm MD5, and the value in the unencrypted form is gonna be 2. Okay, it is 2. Why not like make it 1? Okay, so what we have to do, we have to create the MD5 of 1. For that, what we can do, go to here online MD5 generator. Okay, online MD5 encryption. Okay, let's make our MD5 for 1. 1 for 1 we need, right? 1. It will create the MD5 hash for 1. Okay, this is the MD5 for 1. Let's copy this, go to our browser once again, and here is the value, right? Let's replace our 2 with 1. Okay, now it is replaced. Press enter. Now go back to our application and refresh this. Okay, now we actually logged into other user actually. Okay, you can see like we got another flag. The flag actually changed. Let's copy this and paste this, and whether we found the different flag or not. Yeah, that was the second flag, you can see. Okay, so we found actually 2 flags. You can see here in this is the second user, the home page of second user, and you can see we have the edit access to this post by admin. Okay, edit and delete. But earlier it was we logged in using the user, right? User. In that we don't have access to delete or edit the admin's post. So that's how you can see there is difference. We logged in by changing by manipulating the that by manipulating the parameter present in the cookie. Okay, so IDOR is can be the cookie can also be vulnerable to IDOR. Okay, so I just gave you a perfect example for cryptography and IDOR in like the vulnerability associated with cryptography and IDOR simultaneously. Okay, so we found 2 flags actually. Hence, yeah, the flag 0 found, and we found the flag 5 actually. Okay, they also give you hints. So I think you can find like you can search for all other flags by yourself, and that would be like a great learning experience. So that would be all for this session. I hope you got most of what I taught. You must go through it once again and you will understand everything. It's not really tough. So, sir, thank you for inviting me. That would be all for this
Yeah, Harsh.
session.
So, yeah, any more questions from the audience? Jeff, you want to ask something? Jeff is the student lead for the cybersecurity club in our college.
Oh, that's great, Jeff.
Yeah, Jeff, you want to ask something?
Anything like not just related to this session, anything related to security or communities. If you like want to grow, you must be associated with any community. Okay, in college it's fine, you are doing very great, you are lead of security club in your college. Do try to like associate yourself with community outside your college, just like OWASP. I'm the leading the OWASP chapter in my city. You can also try to like participate and volunteer in DEF CON, if you know like what's DEF CON. Anything, Jeff, you want to ask? Can you suggest some communities? Yeah, start with OWASP. Okay, there are 2 communities that are mostly active in India. First, let me share. Okay, so 2 communities active in India are first is OWASP. Okay, so communities active in India are okay. Pen drop. First is OWASP. Okay, they are active using the chapters present in different cities. You can try to find any chapter nearest to your city, or if they have in your city. And one is null. Okay, null. Okay, that is also active. Okay, so these two communities are active in India. Other than that, if you want to like interact with persons that globally, you must look for DEFCON. Okay, I'm also like I am also a like moderator at AppSec Village. AppSec Village in DEFCON. Okay, moderator at AppSec Village in DEFCON. So yeah, you must, and for now you must look upon this too, OWASP and null community. Okay. So anything else, Jeff?
Yeah, they're also planning to conduct the CTF this week.
Oh, that's great. Can you actually, we are conducting a CTF this week for our college student. I'm pretty sure this session will boost the participation. Absolutely. CTF is like you get to learn a lot. If you, even if you don't know anything, just participate. You look like how others are solving the challenges. Like, most of them I've seen, like after the CTF gets completed, most of them like release the walkthrough, like how a particular challenge has to be solved. Okay, so I hope you will also be doing that. The walkthrough is like the solution and the way by which you actually solve the challenges. So do share the walkthrough as well after the completion of the CTF. So
Any more questions from the participants? Yeah,
I
Jeff,
hope you guys liked the session.
Any more participants wanna ask questions to Harsh? You can unmute yourself. I think the option was previously disabled. Yeah. Any more questions? Yeah, so Harsh, it was a fantabulous session. So we're really so happy that you're part of the Open Source Summit. So it is great to have you. I think it was very beneficial for all the students and faculty out there. And I hope more students and faculty can get associated with you. You have already shared your contact details also. So thank you so much. So we'll keep in touch. Thank you.
Yeah, thank you, sir. And thanks for having me. It was really great. And yeah, do let me know if you have any future sessions such like that. You have such summits organized by the college.
Yeah, sure.
I will be happy to help.
Sure. If possible, I'll also help Jeff connected with you.
Yeah, definitely. You can, I have shared my number and you can just ping me on WhatsApp. Okay.
Sure.
Okay.
So thank you, Harsh. Yeah.
Thank you. Thank you, sir.
So participants, tomorrow we've got some exciting sessions especially from the blockchain track. We have Julian Gordon, Vice President Asia Pacific Hyperledger of Linux Foundation Public Health, with a keynote session. Followed by we have I'm sorry. Yeah, we have a session on hands-on workshop on Introduction to Hyperledger Fabric by Krishna Surya Narayanan. He's a senior research software engineer at IBM India Research Lab, Bangalore. And we also have the director of Nano Foundation. So Nano has created a buzz right when we had the Elon Musk tweet regarding the environment friendliness of the Bitcoin and something like that. So Colin Lemahue, he'll be talking on adversity in open source financial networks. He's the director of Nano Foundation. And slightly off the track, we have Saptak Sen Gupta, who's a human rights centered web developer. So at 2:30 p.m. IST, we'll be having his session, making fast accessible websites using static site generators. So hope you'll be joining for tomorrow's session. So thank you. Thank you for attending the day 3 session. Take care, and we'll see you all back tomorrow. Bye. Take care.